So I'm told that there are only blue cubes, yellow cubes and green cubes in a bag, and that there are twice as many blue cubes as yellow cubes. So whenever we are given something like this, where we are not given the actual value, just use algebra. So yellow cubes is something that we don't know the value of. So we're going to say that yellow cubes is equal to x. Then I've been given information about the blue cubes. So I know that however many yellow cubes, there are twice as many blue cubes. So therefore, I know that whatever the yellow cubes are times by 2 is blue. So 2 times by x, which simplifies to just 2x, is an expression for the blue cubes. And then I know that there are 4 times as many green cubes as blue cubes. So green cubes is going to be equal to 4 times by however many blue cubes there are, which is 2x. And 4 times 2x would simplify to 8x. If you're still getting a little bit confused with the algebra, just remember to split it all up. So in algebra, everything that is next to each other, all the letters and terms, if they're next to each other attached and they're coefficients of one another, then you can just split them up like this and then multiply the numbers and then whack the letter back in. So there are my expressions for yellow, blue and green. Now Hannah takes at random a cube from the bag. Work out the probability that Hannah takes a yellow cube. So the chances, if I just put this into a ratio, because that's 1x, I could say that's 1, that's 2x is 2, 8x is 8. So I know that the cubes are going to be in the ratio 1 to 2 to 8. And probability is always out of the total that you have. So in total, I could say I am going to do a probability out of 11, because 8x plus 2x plus x is 11. And a yellow cube has a probability of 1. So I'm just going to say the probability of her getting a yellow cube is 1/11. In this question, you're being asked to, first of all, rotate trapezium T 180 degrees about the origin. And the origin is just the point 0, 0. So I'm going to do my rotation around here. Now, I don't have a virtual tracing paper that I can show you, but what you do is you take your tracing paper, you put your pencil on the origin, you draw a rough sketch outline of this, and then you turn the page a quarter turn. So a quarter turn is 90 degrees and a half turn is going to be 180 degrees, just like the degrees in the circle. So if you did that, you would then end up with the coordinates over here and your trapezium. I'm just going to get rid of the fake tracing paper, would look like this. Okay, so you've got your tracing paper, you mark the little points, and that's how you do your rotations. So they're nice and simple, and you mark that A. Then I'm told to translate trapezium T by the vector -1, -3. Now remember, vectors, they tell you the distance, the distance and the direction. So all vectors are written with their x instruction at the top and their y instruction at the bottom. And if it's a positive x, I don't know why I did an up arrow. If it's a positive x, it's going to go in the right direction. If it's a negative x, it's going to go in the left direction. And if it's a positive y, it's going to go up. And if it's a negative y, it's going to go down. So I've been given the instruction -1, -3. So I know it's going to go 1 to the left and 3 down. So sometimes helpful to just write the instructions out so that you don't just get confused in the exam flurry. So pick 1 point on your trapezium and I'm going to translate it 1 to the left and 3 down. So 1, 2, 3. And that's going to be that point. Now, if you're feeling confident with just drawing the shape, you can just draw it like that, because you know the lengths of all of the sides. But if you need a bit more confidence, or you just want to double check, pick another point, go 1 left and 1, 2, 3 down. And then you can feel confident that you've done it. So that's how we do that. It's helpful to just write out the things that we remember. So with my index laws or laws of indices, the law of multiplication is that when I'm multiplying indices, I can add the powers together. So I know that p to the power of 3 times by p to the power of x equals p to the power of 9. Therefore, p to the power of 3 plus x must equal p to the power of 9. And what I can do is just look at this, equate it to this. So I know that 3 plus x must equal 9. If I subtract 3 from both sides, I know that x must be equal to 6. I can always double check it. So does p to the power of 3 times p to the power of 6 make p to the power of 9? Yes, because 3 plus 6 makes 9. For the next one, we've got the law of brackets. So when you're multiplying indices in brackets, the quick shortcut version of the law is whatever the power is inside the bracket, you multiply it with the power on the outside of the bracket. So that would become am times m. So I know that 7 to the power of 2 times by the power of y is the same as saying 7 to the power of 2 times by y. And I know that equals 7 to the power of 10. Once again, I can make my little equation. I know that 2 times y must equal 10. So therefore, I can solve it. And if I divide both sides by 2, I know that y equals 5. Okay, so this next question is slightly trickier, so I just changed it on so it has a whole slide of its own. So questions like these are becoming a little bit more common. They are quite unconventional and they're maybe not what you're used to seeing. But the key thing is whenever you have any index laws, one of the key fundamentals is that they must have the same base. So in order for you to use index laws, numbers must have the same base. And hopefully you see that the base over here is 100 and the base over here is 1000. Therefore, the laws of indices cannot work on this calculation unless I manipulate it so that these numbers are rewritten as something that has the same base. Now, it's 100 and 1000. Some people might think to themselves, oh, I could write it as 100, both as a base of 100 because 100 times 10 makes 1000. But if you did write it as 100, then you can't really, you'd be multiplying it by 10 to the power of 1 and you can't compare them so well. So the best thing to do would be to write them as powers of 10. So how do you write 100 as a power of 10? Well, 100 would become 10 squared, okay? And that would end up being to the power of a. So all I've done is instead of saying 100 to the power of a, I've rewritten 100 as 10 squared. Now what I want to do is do the same thing with 1000b. So what's 1000 as a power of 10? Well, 10 times 10 times 10 is 1000. So therefore I could rewrite that as 10 cubed to the power of b. So all I've done is I've written my calculation so that I now have common base numbers because then the laws of indices apply. And I know that this can be written in the form 10w. So now what do I do when I am multiplying indices in brackets? Well, I multiply the powers. So that would become 10 to the power of 2a times by 10 to the power of 3b must be equal to 10 to the power of w. And what is the law for multiplying indices? When I multiply indices that have the same base, I simply add the powers. Therefore, I can form an equation and 2a plus 3b must be equal to w. And the question is asking me to prove that w equals 2a plus 3b, and that is how I would do it. I could rewrite it as w equals 2a plus 3b if I'm being pedantic, but they mean the same thing. So the trick is always think to yourself, oh, okay, these numbers don't have the same base. Therefore, let me see if I can rewrite them. 10 is a nice common factor of both of them. I can both. In this question, I have been given a trapezium and I'm asked to work out the size of angle CDA. So it's always really helpful to just start by colouring in the angle that you're being asked to work out. So CDA is this angle here. Now, I'm asked to work that out and give my answer to 1 decimal place. So what can I do in order to work out this angle? Well, in order to work out an angle, I want to use a triangle. So I'm going to have to figure out information about this triangle here. So I can just form this as a nice triangle. And if I'm dealing with right angle triangles, I know it's a right angle because, well, it's a trapezium, and I know that this line here is a right angle, so therefore this one would be a right angle too. So let's have a think. What information do I know and what information can I find out? I know, first of all, that over here I've been given a right angled triangle, and I know the length of one side, another side, and this length here I do not know. So when I've got a right angled triangle, I can either use Pythagoras, and that is going to be if I know the lengths of two sides and I'm trying to work out the third side. I'm going to use trigonometry if there's angles involved. So with Pythagoras, I know that a squared plus b squared is c squared. That's Pythagoras' theorem. Whenever you have the longest side, so you always know which side is the longest because it's the side that is opposite the hypotenuse. Whenever you have the longest side, you rearrange the equation. So c squared take away a squared must equal b squared. I can substitute that in. So 7.5 squared take away 6 squared is going to give me b squared. And remember, the sides don't matter, a and b, it doesn't matter, they're both just the shorter sides. So 7.5 squared take 6 squared gives me a value of 20.25. So to work out b, the final step is to do the square root, which gives me square root of answer is 9/2, which is 4.5. So I now know that this length over here is 4.5. I don't know if I've drawn over it, but whatever that would have been. Have I drawn over it? No. So I can just call that length 4.5. I'll just label it there. I don't have to call it anything. Now, the reason I found that is because in order to find this length here, I can only do that if I know this total length here. And I don't know that. I only know that this length is 10. Okay, so if I know the total length here and I subtract this length, this total length, I would be given the length, is that C? This is what? No. Once again, they haven't labelled everything, but it doesn't matter. I'd work out that length here. So the total length of the bottom of the trapezium is 24 centimetres. I know that this length here must be 10 centimetres because it's equivalent to its upper part. So 24 take away 10 take away 4.5 is going to give me the missing length that I need. And 24 take away 10 take away 4.5 gives me 9.5. So I know that this little bit of my triangle that I'm trying to work out is 9.5 centimetres. And it sometimes helps to just draw out the triangle again separately to what you're doing. So I know this length is 9.5. This is the angle I'm trying to work out. So what other information would I need to know? Well, I'd either need to work this out or this out. And thankfully, if I just get rid of all of the scribblings, I have been given the height of the trapezium. So I know that this height here must be 6 centimetres because this height here is 6 centimetres. So this length here is going to be 6. Now, if I know two sides and I'm trying to work out an angle, then I can use trigonometry. So with trigonometry, the best advice I can give you is to actually just write out your SOHCAHTOA, because the amount of people, including myself, that just make mistakes because you're rushing and you just mix up the sides by accident. So which sides have I been given and what am I trying to find? Well, this is my given angle, so I label everything accordingly. So this 6 is opposite my given angle, and this side here is adjacent to my given angle. Which ratio uses the opposite and the adjacent? O and A, that's tan. So I can write out that tan theta must equal the opposite over the adjacent. And remember, theta is just the sign for an angle from the Greek alphabet. So tan theta, if I substitute my values in, the opposite is 6 and the adjacent is 9.5. And whenever I'm trying to work out an angle, I always have to do this thing called like in your calculator, you press shift and then tan. It's the inverse of tan. It's the same as dividing by tan, but our calculators don't like it when we do that. So we press shift tan. So I'll write that here. You press shift tan and then use the fraction button to write 6 over 9.5. So 6 over 9.5. Close the bracket because otherwise you won't get the calculation, and that gives me a value of 32.2756. They want it to one decimal place, so again circle the first digit, look next door. If it's more than 5 you're going to round up, so that would be 32.3. Okay, so this is a calculator question, and the key thing here is knowing how to use our calculator and to enter things on it accurately. So I know that I want to work out the square root of whatever is in this fraction. So the first thing that's happening is that I want to press the square root button. So you start by pressing your square root button, okay? Then you know you've got a fraction inside it, so you press your fraction button. So you have a big square root sign with 2 little fractions inside. And then we can enter our values. So sine 25 plus sine 40 over cos 25, close the bracket, take cos 40. Remember, when you're dealing with trigonometry, always close the bracket. And then we press equals. So you've got everything in your calculator and you press equals, and it says write down all the figures on your display. So the amount of people that just write like one decimal, just write down what the question is asking you. So we'd write 2.7560397. Okay. And now the second part is asking me to write it correct to 2 decimal places. So to 2 decimal places, I circle the second digit. I look next door to decide whether I round up or down. It's more than 5, so I know I'm going to be rounding up. So that would become 2.76. Okay, so in this question, I'm told that Jessica invests £20,000 in an account paying compound interest for 3 years. In the first year, the interest rate is X%. So I don't know what the interest rate is. But at the end of the first year, her investment has a value of 21,100. So how do you work out compound interest? You have your original value times by your multiplier, and then to the power of the number of years. But we know that it's just 1 year that we're working out. So what I'm going to do is write £20,000, my original value, times by my multiplier. I don't know what that is. For now, I'm just going to say Y. And when we do multipliers, you always do it, so I know it's increasing, so you do 100% plus your interest rate. So times by Y% must equal 21,100. So to figure out what my multiplier is, I'm going to do 21,100 divided by 20,000. And that gives me 21,100 divided by 20,000 is 1.055. 1.055. So I know my multiplier is 1.055. So if I think to myself, 100% plus something divided by 100 gives me 1.055. The interest rate is essentially this bit over here. So the interest rate, X%, is 5.5%. Now, if I know what the interest rate for the first year is, I can use that to figure out what the interest rate for the next 2 years would be. So the interest rate for the second and third year is X divided by 3. So 5.5 divided by 3 is probably going to be a nasty number. So when I do my compound interest, I can just write it as a fraction. So I'm going to say 21,100 times by, or I think I have to add it actually. So 5.5 divided by 3 is 11 over 6, which is 1.83 recurring. So my new interest rate, X over 3, is 1.83 recurring. So if I think about my multiplier, 100% plus 1.83 recurring, if I add that together and then I divide by 100, that gives me 1.0183 recurring. So if you're a bit confused about multipliers, then start with 100%, add on your interest rate and divide by 100. So I'm going to do 21,100 times by 1.0183 recurring, to the power of 2 because it's for 2 years, for the second and the third year. So 21,100 times by answer squared is £21,880, 75861. So to round it in money, that would be £21,880.76. Okay, so in this question, I have been told that 200 students chose one language to study. Each student chose one language from either French, Spanish, or German, and then I'm told information about these students. So I know that each student has a choice to study French, German, or Spanish. And then what other information do I know? I know that out of these 200 students, 90 are boys and the rest are girls. So I know that the options are to study French, German, or Spanish, and that if you studied French, German, or Spanish, you are either a boy or a girl. So I can just set up a table for myself, which allows me to see what's happening. So I know that 90 of all of the people that study, of all of the students, are boys. So I can fill in my totals column here. So you're essentially constructing a two-way table for yourself. So I know 90 are boys and the rest are girls. Well, what's the total of all of the students? The total is 200. So if there are 90 boys, I know that that must mean that there are 110 girls. I'm then told that 70 chose Spanish. So in total, 70 students chose Spanish. I then know that 60 of the 104 students who chose French are boys. So how many students studied French in total is 104, and 60 of those are boys. So I can figure out how many are girls. If there's 104 in total, 104 take away 60 is 44. I'm also told that 18 girls chose German, so I can fill that in here. And that is all the information that I have so far been given. So now it's kind of just like figuring out the missing pieces. If I look at my totals column, I know that the total amount of students that study French, German, and Spanish must sum to make 200. So 200, take 104, take away 70, leaves me with 26. So I know the total amount of students that study German would be 26. I then have only one missing piece of data here. I know the total amount of students that study German is 26. 18 of these are girls. So 26 take away 18 leaves me with 8. And then I'm just left with two other columns. I know that there's 90 boys in total. 60 study French and 8 study German. So if I did 90 take away 60 take away 8, that leaves me with 22. I could fill out the last little missing piece just by doing 110 take 44 take 18, which leaves me with 48, and then my full two-way table is complete. But I'm being asked to work out how many boys chose Spanish. So all I need to do is get to this part here where I figure out how many boys chose Spanish, and that would be... Okay, so in this question, I am told that Karina has 4 tanks on her tractor, and that each tank is a cylinder with diameter 80 centimetres and height 160 centimetres. I'm told that the 4 tanks are to be filled completely with a mixture of fertiliser and water, and the fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser, and does she have enough fertiliser for the 4 tanks? So the first thing that I want to do is figure out what the total volume of the tanks are. So how do I work out the volume of a cylinder? Well, to work out the volume of any prism, what you want to do is work out the area of the cross section, and you multiply that by the length or the height or whatever you call it, the bit that isn't involved in the area of the cross section. So what's the area of this cross section here? That's a circle. The formula for the area of a circle is pi r squared. So I know that the diameter of this circle is 80 centimetres, and a diameter is 2 lots of the radius, so therefore the radius must be 40 centimetres. So I can just substitute that into my equation. So the area is going to be pi times by 40 squared. Now I can just leave that in terms of pi for now because I'm not being asked to round anything yet. I only want to round at the very end. So 40 squared is 1,600. So that area of the top part is 1,600 pi. Now what do I do to work out the volume? Well, I work out the area of the cross section, which is 1,600 pi. And then I multiply it by the length, which is 160. So 1,000, so the volume is going to be 1,600 pi times by 160. And 1,600 pi times by 160 gives me 256,000 pi. Now that's the volume of one cylinder, and I have 4 cylinders. So I'm going to multiply that by 4, which leaves me with quite a large number, 3,216,990.877 centimetres cubed. Now I've been given a vital piece of information, which is that 1 litre is equal to 1,000 centimetres cubed, and that's because 1 milliliter is equal to 1 centimetre cubed. So what I want to do to turn my centimetres cubed into litres, I'm going to divide by 1,000 to get it to litres. So divided by 1,000 gives me 1,024 pi. So I know that the total volume of all 4 cylinders is 1,024 pi. I could convert it into decimals if that makes life easier for you. So that would be 3,216.990,877 litres. Now I know that the fertiliser has to be mixed with water in the ratio 1 to 100. So 1 part fertiliser to 100 parts of water. So in total, I have 101 parts. So what I want to do to work out how much fertiliser I need is divide by 101. And that gives me 31.85139,482. So I need 31.85 litres of fertiliser in order to fill these tanks correctly. She has 32 litres of fertiliser, so I would say yes, she has 31.85 litres. So in this question, I'm told that Jackie buys a pack of 24 packets of crisps and that it costs £3.65. She then sells all 24 packets of crisps for 40p each, and I need to work out the percentage profit. So I know that the original cost is £3.65, and then I want to work out how much she sells it for. So if I do 24 times by 0.4, that gives me £9.60. So she sells them for £9.60. So the profit she makes would be anything she sells it for minus the cost. So £9.60, take away £3.65, gives me £5.95. So the difference between how much the cost and how much she sold it for is £5.95. I write that over the original cost, and then I times it by 100 to work out her profit. So £5.95 divided by £3.65 times by 100 gives me 163.0136986. I need to write this answer correct to 1 decimal place. So I look over here, this is not greater than 5, so I just leave that as 163.0%. It's important because it says to 1 decimal place, you want to have 1 decimal place after your answer, even though it's a 0. So her percentage profit is 163%. To double check, what we could do is 3.65 times by 1.63. And does that get you to £5.95? Yes. So here I've got a bearings question. So I'm told that the bearing of a ship from the port is 126 degrees. So let's try and draw a diagram. With bearings, you're always going to get like parallel lines because you always start your bearings from due north. So the bearing of a ship from the port is 126 degrees. And if you just think about your angles in general, so you know that's 90, 180, 270, you know 126 is going to be roughly like that. So we can draw a bearing that looks roughly like that. I know that this angle is 126 and this is the port. So this is where the ship must be. So the bearing of the ship from the port is 126 degrees, and I need to find the bearing of the port from the ship. So we always start from where it says from. So we're going to start from the ship, and remember every bearing starts from due north, just so that we can have consistency. And you always have to start from due north and go round clockwise. So I'm going to have to go round this way until you reach the line, and that is going to be the bearing of the port from the ship. So in order to do this, I use my knowledge of angles on parallel lines. So these two lines, due north, are parallel lines. So therefore this angle and 126 must sum to 180, because co-interior angles sum to 180. So 180 take away 126 is going to give me 54 degrees. Obviously use a calculator if you need to. And then I know that angles on a point must sum to 360. So I just do 360, take away 54, and that leaves me with 306. So the bearing of the port from the ship is 306 degrees. The key things about bearings: you start from due north, you go clockwise until you reach the line, and your bearing must be a 3-digit number. So if I got 54 degrees, I would write that as 0. Okay, so here I've been given a diagram of a rectangle and a triangle, and I'm told that the area of the triangle is 13.5 centimeters greater than the area of the rectangle. And then I need to find the perimeter of the triangle. So how do you work out? Let's start with the rectangle. The area of a rectangle is always base times height. So I'm going to do 6 times by 3x plus 2. And I don't need to write the times, because when I'm multiplying two terms or more, I can put them in a bracket. So I know that's the perimeter, the area of the rectangle. And then the area of a triangle, how do you work out the area of a triangle? It's base times height divided by 2, a commonly forgotten thing, especially under exam pressure. So that would be 5x times 7 is 35x divided by 2. And I know that the area of the triangle is 13.5 centimeters squared greater than the area of the rectangle. So therefore I'm going to add 13.5, because whatever this area is plus 13.5 is equal to this area. That's why I formed an equation for myself. So now I can just expand everything. So that would be 18x plus 12 must be equal to 17.5x plus 13.5. And I have a double-sided equation, and now I can just move things from one side to the other until I solve it to find x. So I could take away 17.5x. So I know that 0.5x plus 12 is 13.5. And then I subtract 12 from both sides. So 0.5x must be equal to 1.5. So I know that x divided by 2, like 0.5 is equal to a half, must be equal to 1.5. Therefore, if I times both sides by 2, I know that x is equal to 3. Now that I know what x is, I can substitute that in to figure out what the perimeter of the triangle must be. So if x is 3, then 5x must be 15. 5 times 3 is 15. So I've got a triangle, and I need to work out its perimeter. It's a right angle triangle. So I've got 7, 15, and I can use Pythagoras to figure out its hypotenuse. So Pythagoras is a squared plus b squared equals c squared. So that must mean that 7 squared plus 15 squared must equal c squared. So I can type that into a calculator. 7 squared plus 15 squared equals 274. And then the final part is to just square root in order to get your value of c. So square root 274 is c, so therefore c is 16.5529 and so forth. Now I need the perimeter. So the perimeter is just the distance around the outside of the shape. Imagine you're just a guard walking around the perimeter. So I'm going to do 7 plus 15 plus 16.55. So I add all those values together, plus 7 plus 15, and I'm left with 38.5529. It says give your answer to 3 significant figures. So I'm going to round this digit, so that would be 38.6. I circle the digit, look next door. If it's more than 5, then I'm going to round it up. So x is 38.6. Oh, well, that's supposed to say the perimeter. Perimeter equals 38.6. In this question, I've been given a probability tree. I'm told that one weekend, the Keddy family is going to do a sports quiz and a music quiz. The probability that the family will win the sports quiz is 0.3, and the probability that the family will win the music quiz is 0.35. Now, the key thing with probability is that it always sums to 1. So the probability of something happening and the probability of something not happening must make up 1. Like if the probability of it raining tomorrow is 70%, the probability that it does not rain is 30% because the only option is rain or not rain. So bearing that in mind, when you've got a probability tree, your branches must also always sum to 1. So I know that if the probability that the family will win the sports quiz is 0.3, the probability that they do not win must be 0.7, because 0.3 plus 0.7 gives you 1. So I can fill that in here. I do the same for the next part. So the probability that they win the music quiz is 0.35, and 0.35 plus 0.65 gives me 1. So I can fill that in over here. So you always want to double check that your branches, each individual little branch, sums to 1. Now, I've been asked to complete the probability tree diagram, which is what I've done just by figuring out what the missing piece is by getting both of my branches to sum to 1. And for the next part, I am being asked to work out the probability that the Keddy family will win both the sports quiz and the music quiz. So I think about what route can I take along my probability tree? Well, if I win the sports quiz, I go along this branch. And if I win the music quiz, I go along that branch. Now with probability, to work out the probability of, let's say, X and Y happening, you always multiply the probabilities. So when you go along your branches, you multiply. So I'm going to do 0.3 times by 0.35, which leaves me with 0.105. So that would be the probability that they win both. I'm being asked to convert 8,000 centimeters cubed to meters cubed. Now, a question like this is really frequently just done wrong because people rush through this and they know that 1 meter is equal to 100 centimeters. So they're like, oh, I'll just divide it by 100. But let's think about what's actually going on. So if I just think about lengths to begin with, so 1 meter is equivalent to 100 centimeters. But that's only when I'm dealing with lengths. When I deal with area, it gets a little bit more complicated. So if I think about it, 1 meter by 1 meter, that gives me 1 meter squared. But when you think about it in terms of centimeters, 1 meter in centimeters as a length would be 100 centimeters. So 1 meter squared is equivalent to 100 centimeters by 100 centimeters, which is 10,000 centimeters squared. So even though 1 meter equals 100 centimeters, when it comes to area, 1 meter squared is actually 10,000 centimeters squared. And when it comes to volume, it gets even larger. So think about it again. If you've got a cube that is 1 meter by 1 meter by 1 meter, then that would be 1 meter cubed. But if we do the same for centimeters, and that was 100 centimeters by 100 centimeters by 100 centimeters, I'd have to work out the volume by doing 100 times 100 times 100, which is 1,000,000 centimeters cubed. So you can just memorize these and know that 1 meter cubed is equivalent to 1,000,000 centimeters cubed, but it's also good to think about why this is happening. So now that I know that 1 meter cubed is 1,000,000 centimeters cubed, what do I do to go from centimeters cubed to meters cubed? Well, to get from 1,000,000 to 1, I divide by 1,000,000. So that's what I'm going to have to do to 8,000. So 8,000 divided by a million is going to give me 0.008. So that is how I would do that question. So take real care whenever you're dealing with centimetres squared to metres squared and centimetres cubed to metres cubed. So another converting metric units question, I need to change a speed of 180 kilometres per hour to metres per second. Okay, so there's a few things I need to think about first. First, I want to change 180 kilometres into metres. So how do I change kilometres into metres? I know that 1 kilometre is equal to 1,000 metres. Therefore, to get from kilometres to metres, I multiply by 1,000. So 180 kilometres is going to be 180,000 metres per hour. So all I've done is turn my kilometres into metres. So I know the speed is 180,000 metres per hour, but I want to get it to metres per second. So I know that in 1 hour, there are 3,600 seconds because there are 60 minutes and 60 seconds in a minute. So how do I get hours to seconds? I divide by 3,600. So I'm going to need to do the same over here. 180,000 divided by 3,600 gives me 50 metres per second. Question, I've been given a cumulative frequency graph with its corresponding table of values. Jen draws this cumulative frequency graph for the information on the table, and I need to write down 2 different things that are wrong with this graph. So let's start by looking at the axes. I know that the y-axis, even though she hasn't labelled it, is the cumulative frequency, but I don't know what the x-axis represents. So the first thing that I would say is that she hasn't labelled the x-axis. You could also call it the horizontal axis, but she hasn't told us what that represents. It should have been time. Okay, next let's have a look. So whenever you plot a cumulative frequency graph, you always plot it against the x value and the cumulative frequency. So your x value is always going to be the upper end of the class interval. So let's see if she's done that. So the first coordinate should have been 10, 4. Has she done that? So 10, 4 would be over here. No, she hasn't. What has she done? She has plotted against the midpoint instead of the upper class interval, or the top end. Okay, so instead of the top end of the interval, you always, when you're doing a cumulative frequency graph, always use the highest value as your triple brackets question, which should technically be pretty straightforward, but the amount of people that get this wrong is unbelievable. So I'm going to show you a way that will help just not miss any tiny little parts out, because when we're dealing with so much multiplication, it's really easy to just miss one little bit out. So what we can start with is just by multiplying our first 2 brackets, which we should be pretty confident with. We're just multiplying double brackets. So x times x is x squared, x times minus 3 is minus 3x, 2 times x is 2x, and 2 times negative 3 is minus 6. We can simplify that. So minus 3 plus 2 is minus 1. So my first bracket, I know, expands to this. So this expands to make this. Now the next part, so once we're dealing with the third bracket, the best thing to do is to put it in a grid, because the amount of people that just miss one term out by accident is unbelievable. So you've got x squared, you've got minus x, and then you've got minus 6. And I should have done the grid a little bit bigger. And then on the other side, we do the final bracket. So x plus 4. And now all we need to do is multiply it in the little grid. So x times x is x cubed, minus x times x is minus x squared, x times minus 6 is minus 6x, x squared times 4 is 4x squared, minus x times 4 is minus 4x, and minus 6 times 4 is minus 24. Okay, so you've got all of your terms, and the cool thing about the grid method is that your diagonals are always going to simplify. So you can write it all out. I mean, you can write it all out bit by bit, or you can just simplify as you go along in your diagonals. So 4x squared take away x squared gives you 3x squared. And then minus 4 minus 6 is minus 10. And then you're left with minus 24. So the final bit, the final answer, as you can see, is just a little bit easier to bring the terms together, because the amount of people that just miss one term or simplify one, or one of the negatives gets in the way, this literally guarantees that you're okay. So in this question, I'm told that a pet shop has 7 guppy fish, 13 tetrafish, and 5 angelfish. And David is going to choose one of the following combinations of fish: a guppy fish and an angelfish. So let's just have a quick little recap of the and the or rule. If you're trying to work out the probability of this and that happening, of 2 things definitely happening, then you multiply your probabilities. If you're trying to work out the probability of this or that happening, you add your probability. So for instance, if I knew that the probability that it was going to rain tomorrow was 65%, the probability of it not raining tomorrow would be 35%. So if I were to want to know what the probability of it raining or not raining is, I'd add them together, and of course they make 100% because you're having more things in the mix. So the or rule, you always add your probabilities, and if you're trying to work out the probability of this and that happening, there's more things that are at play, so the probability generally gets lower, so we multiply. So what's the probability of a guppy fish and an angelfish? So a guppy fish, there are 7 guppy fish, and there are 5 angelfish. So 7 times by 5 is 35. So I have 35 combinations, 35 possible options, because each guppy fish, so let's just say guppy 1, guppy 2, guppy 3, 4, 5, 6, 7. Each of these little guppy fish I can combine with angelfish 1, angelfish 2, angelfish 3, angelfish 4, angelfish 5. Okay, so when I'm doing combinations, I have to use the product rule, so the multiplication rule, because with each individual guppy fish, I have 5 options. So I have 7 guppy fish and 5 options for each of those guppy fish. That's why I do 5 times 7. So people sometimes get confused about it, but if you think about what it actually means, each individual fish can be combined with each individual other fish. So it looks like this strange little tree like that. Then he could have a tetrafish and an angelfish. So a tetrafish and an angelfish. How many tetrafish are there? There are 13 tetrafish. So each of these 13 fish could be combined with an angelfish. So there are 5 angelfish, and 13 times by 5 is 65. And finally, we've got, he could get a guppy fish, a tetrafish, and an angelfish. So he could get a guppy fish, combine that with any of the 13 tetrafish, and combine that with any of the 5 angelfish. So what's that? 7 times by 13 times by 5 is 455. So if he just gets a guppy fish and an angelfish, he has 35 combinations. If he gets the second option, he has a total of 65 combinations, and for the last one he has 455. So we just do 35 plus 65 plus 455 equals 555. So that is how there are 555 different ways for David to choose his fifth. So here I've got a cumulative frequency diagram, and I've got a frequency table. I'm told that the table shows information about the ages of 80 people going on a mountaineering expedition. First part, I need to complete the table. So I know that there are 80 people in total. This is just a frequency table. So the first thing I do is add all my frequencies together. So 38 plus 22 plus 5 plus 3 gives me 68. So therefore, I know that 80 takes 68, leaves me with 12 people. So the missing interval must be 12. Now my frequency adds up to 80 and it's complete. I then need to draw the cumulative frequency graph for this information. So what I'm going to do, and what I'd advise you do if you don't have this like table extended in the exam, is just do an extra little table for cumulative frequency. So the first part is 38. And when I do cumulative frequency, you literally just add on everything beforehand and you keep on running like a running total. So 38 plus 22 is going to give me my next value. So over here is 60, 60 plus 12 is 72, 72 plus 5 is 77, and my final value is 80. The way you know you've done it right is you know the total is 80, so your final value must also be the same as the total. So let's draw the graph. When I'm drawing a cumulative frequency graph, you always plot against the last value. So my first thing is going to be 30 and 38, so over here, then 40 and 60, then 50 and 72, then 60 and 77, so 5, 6, 7, and then 70 and 80. So this is a bit of a strange cumulative frequency, but I just go with it. So we start from 20 and then we just join our dots together. Normally a cumulative frequency graph would look more like that, but you just plot what you're given, and actually that doesn't look that great, so let's just try it again. So there we go, that's more like it. Okay, now use the graph to find an estimate for the number of people aged over 42. So what I do when I'm estimating using cumulative frequency, I go along the axes they've told me, so people aged over 42. So 42 would be here. You draw that with a ruler, but I don't have one. And then you go up to the graph, and that tells you that's 61, 2. Okay, so from 62, that is your cumulative frequency. I want to know the people aged over 42, so it's going to be everything over 42. So from 62 to 80, 80 takes 62, gives me 18. So therefore, there must be roughly 18 people over the age of 42. Okay, next. The youngest person on the expedition is 23. The oldest is 62. Use the information from the cumulative frequency graph to show the distribution of ages. So for a box plot, you always plot it like this, where this is your least value, this is your greatest value. The box ends at the lower quartile and the upper quartile, and this represents your median. So from my cumulative frequency graph, I'm going to need to get the lower quartile, the median, and the upper quartile in order to complete this. So let's quickly go back. The lower quartile is going to be a quarter of your data. So a quarter of 80 is 20. So I go across 20 down my graph to, that would be 26. So the lower quartile is 26. The median is half of your data. So that would be 40. And I go along 40. And then, is that 2? I think that's 1. And then down to 31. So my median is 31. And the upper quartile is 3/4 of your data. So 3/4 of 80 is 60. So I go along and then down to 40. So my upper quartile is 40. I then have all the values I need to draw my box plot. So my least value is 20. So I need to actually design an axis. So I know I might start at 20. Let's see if that's enough. 30, 40, 50, 60, and 70. So they've given us a nice one. So 23 would be 1, 2, 3. That's my least value. My greatest value is 62. So I draw a line here. My lower quartile is 26. So 25, 26. And my upper quartile is 40. And then the median is 31. So I draw the lines, and then maybe I made it a little bit too big. So I'm just going to chop that off. Imagine that it's just got those bits chopped off. Oh, it chopped off the whole thing. Okay, well, yeah. So that's how I draw my box plot. Now, what does the box plot tell you about the distribution of data? Well, it tells me that 75% of the adults are under 40. So the cool thing about the upper quartile and the lower quartile, this data here represents the middle 50% of the data. This is the bottom quarter, bottom 25%, and this is the top 25%. So basically the spread of data, there's a lot more people, a lot more younger people on the expedition. So 75% of the adults are under 40. And that's all we need to say because we're not comparing it. Here I've got an error interval, but it's a slightly different one that people frequently just overlook because truncation is kind of like this weird thing that you're like, why do I do this if I know how to round? So when I truncate, let's just give a random example, 6.47983. When you truncate, you literally chop off where it says, so to one decimal place, if you truncated it, you literally just would write that as 6.4. You don't consider rounding at all. If it was to 2 decimal places, it would be 6.47. And if it was to 3 decimal places, it would be 6.479. So you literally just chop off anything after your decimal and you just leave it as it is. You don't worry about rounding. So that's what truncation means. So I know that crisps are packed into 30-gram bags, okay, truncated to the nearest gram. So what that must mean is that it's rounded to the nearest decimal place. So the lowest possible value it could be, if I think about my decimal places, it could be 30.000986, blah, 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 blah. So the lowest possible value it could be is 30, because if I truncated it, the first digit could be 0, the second digit could be 9. It doesn't matter because I'm truncating. So the lowest possible value would be 30. If it was 29.99 whatever, then to the nearest gram, I would have just truncated it to 29. So that's why 30. And then, because it's been truncated to 30, I know that it must be 30 point something. The highest possible value it could be is 30.9 recurring. But because the error interval says less than, I'm going to say it would be 30 to 31, because it could technically be 30.9 recurring. So anything under 31 is what it could be. And that's how I do an error interval with truncation. And next we've got some linear equations. So remember, when you're being asked to solve something, all that means is work out what the value of that variable is. So the variable we've been given is x. So let's see what we can do. Well, first thing I could do is expand the brackets. Okay, so I've got x over 8, x plus 8 over 3 equals 2x plus 6. I've just expanded the brackets. Remember, when you're expanding, you multiply the term on the outside by each term on the inside. Then what could I do? Well, x plus 8 is being divided by 3. So remember, if you have your little flow diagram, just to remember what the order of operations are occurring in, you could do that, or you might know how to do that without needing to do a flow diagram. So you know that the first thing you need to do is multiply both sides by 3. So we've got x plus 8 equals 3 lots of 2x plus 6. Now, if you're multiplying two terms by the same thing, you can put it in brackets. Or you could have multiplied it and expanded the brackets out, up to you. So let's expand them. X plus 8 equals 6x plus 18. And then what could we do? Subtract take this x from one side to the other. So when you've got x on both sides of the equation, all you want to do is move the smallest one from its side to the other side. And remember, to move anything from one side of the equation to the other, we do the inverse operation. So we'd be left with 8 equals 5x plus 18. We'd subtract 18 from both sides. So 8 take 18 is negative 10. So 5x equals negative 10. Therefore, x, if we divide both sides by 5, is negative 2. And that's your answer. Okay, so in this question, I'm being asked to factorise this quadratic. Well, I'm being asked to solve it, but in order to solve it, I need to factorise it. So once again, I've got quadratic and it's got a 2x squared. So I might want to set myself up a grid like this just so that I can figure out what's going on. So I know that my numbers must multiply to make negative 12. So what could that be? Well, minus 2 times 6, minus 12 times 1, minus 3 times 4, or the reverse. So which would multiply together to make negative 5? Well, let's have a try. So the beauty of this method is that you can just draw them out, put them in pencil, rub them out. So let's have a think. 2 lots of something, well, maybe I'm going to try this. So 2 times by 4, and actually I'm going to try negative 4 because it needs to become negative 5. So 2 times negative 4 is negative 8x, and 2 times x times 3 is 3x. Negative 8x plus 3x gives you negative 5x, and obviously 3 times minus 4 is minus 12. So in your brackets you'd have 2x plus 3 and x take 4 equals 0. So we've done the factorising part. If you need help with factorising these, just watch a video on factorising. I'm just going to go this quite quickly because we've got a lot to go through. So when you've got your quadratic in this form, how can you solve it? Well, you have to rearrange it to make x the subject. So what could we do? Now, a lot of you might know that when you're solving a quadratic, you just make it equal to the inverse of what's in the brackets. But let me just show you why we do that. If we divide both sides by x take 4, what would we be left with? Well, 0 divided by anything is 0. So you're still left with 2x plus 3 equals 0. Then let's solve it. 2x would be negative 3 and x would be negative 3 over 2. So that's why we do the inverse of the bracket. So that's your first value. And then you do the same for the other bracket. So let's say that we've divided it by, let's say we have 2x plus 3, x take 4 equals 0. And we divide by this bracket. What are we left with? We're left with x take 4 equals 0. Therefore, x equals 4. Okay, so when you are solving a quadratic, first thing you do is factorise it, make it, it's already equal to 0, and then divide each bracket one by one. 0 divided by anything is 0, and that's why you can solve your equations. Slightly trickier one, but doing the same things nonetheless. So you've got a fraction. Whenever you have a fraction, you want to just get rid of it by multiplying both sides by the denominator. So multiply both sides by minus 3. So you'd be left with y, brackets x plus 3, equals 4x take 1. Remember, the reason you do the inverse is because it cancels itself out. Now you've got this nice little equation. Let's expand the brackets. So yx plus 3y equals 4x take 1. Now this, what can I do? Well, I want to make x the subject. So that means I want all of my x's to be on one side. So let's take 4x from both sides. So yx plus 3y take 4x equals negative 1. I obviously want to move the 3y to the other side because that's getting in the way. So do the inverse. So yx take 4x equals minus 1 take 3y. Now this is where a lot of people come undone. But all you're doing is you've got two lots of x, 2 terms that have x in it. So all you need to do is factorise it. And then you've got x on itself. So x is common to both of these terms. So if I factorise it, I'd be left with x brackets y take 4 equals minus 1 take 3y. And then I can just divide both sides by y take 4. And that's all you need to do. Now, it's never really nice to leave something as a negative. So what we could do is multiply both sides, both parts of your fraction by -1. So x would be 3y plus 1, or 1 plus 3y over 4 take y. And that's your final answer. Okay, so in this question, we are being asked to show that two fractions add together to and rearranged to make a quadratic. So the most important thing that we need to remember about adding or subtracting fractions is that they need the same denominator. Now with algebraic fractions, it's generally going to be the two denominators multiplied by each other. That's the lowest common multiple. So our denominators are going to be x take 2, x take 3. And then let's think what I need to do back to my fractions in order to achieve that denominator. So the first fraction has been multiplied by x take 3. And whatever I do to the denominator, I must do to the numerator to keep the fractions equivalent. So that would become 3 brackets x take 3 plus, what have I done to this fraction? Well, I've multiplied the denominator by x take 2. So I must multiply the numerator by x take 2 as well. Now, because they both have the same denominator, I can simply add the two fractions together. So let's expand it before we do that. So that would become 3x take 9 plus 2x take 4. Okay, now I could simplify that even further. So 3x plus 2x would give me 5x, and -9 take 4 is -13 over, and let's expand this quickly. So x times x is x squared. X take 3 is -3x. Minus 2 times x is -2x. And -2 times -3 is +6. So that would be simply x squared take 5x plus 6. Now let's make it equal to 5 because that's what we've been told. And what could we do? Well, let's rearrange it by multiplying both sides by the denominator. So we'd be left with 5x take 13 equals 5x squared take 5x plus 6. If we expanded that, that would give me 5x take 13 equals 5x squared take 25x plus 30. And then all I need to do is just rearrange it slightly. So let's take 5x from both sides. That would give me -13 equals 5x squared take 30x plus 30, and let's add 13. So we're left with 5x squared take 30x plus 43 equals 0. Now that is actually supposed to say 43. Sorry. That anything to the power of 0 is 1. If not, go back on the video and we went through why that is. Now over here we've got 4 to the power of 8 times 4 to the power of -3. When we're multiplying indices, so a to the power of x times by a to the power of y, all we do is add the indices together. So in this case we'd say 4 to the power of 8 plus -3. So that gives me 4 to the power of 5 over 4 to the power of 2. I've just simplified the top. 4 to the power of 5 over 4 to the power of 2. Well, when I'm dividing indices, so a to the x divided by a to the y, I just subtract the powers. So 5 take 2 gives me 3. So the value of n is simply 3. Now over here, I've got a little bit of a trickier one. So I know that 3 to the power of y times by 3 to the power of 3y is 16. Now what do? The laws of indices state that when you are multiplying indices, you add the powers. So therefore I know that 3 to the power of y plus 3y must give me 3 to the power of 16. So I can extract that as a little algebraic expression. So y plus 3y must be 16. Therefore 4y is 16. Therefore, divide both sides by 4. Y is 4. So if y has a value of 4, 3y would be 3 times 4, which is 12. So 3 to the power of 12 is what I need to do. Now it says work out the value of 3y, so I would have to do 3 to the power of 12, but I think I just miswrote that question. So I think it just meant work out the value of the 3y in that, and the value of the 3y would be 12. If not, you could do 3 times 3 multiplied by itself 12 times, but that is not what the question should be asking. Okay, so a quick little recap on fractional indices. Now, when you've got a fractional indice, all it means is the base power over here, that tells you what is to the root of, and the numerator tells you what it's to the power of. So in this case, it would be the cubed root of 8 to the power of 2. So what's the cubed root of 8? Well, that would be 2. So I'd be left with 2 squared. And what's 2 squared? 4. And that's all I need to do. Now, it gets a little bit trickier over here with negative indices. So when you see a little negative, all that means is it's the reciprocal. So that would be 1 over 8 to the power of 5 over 3. So once again, what is the base mean? It means the root. So that's the same as 1 over the cubed root of 8 to the power of 5. What's the cubed root of 8? We just said that was 2. So I'd be left with 1 over 2 to the power of 5. And 2 to the power of 5 is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2 again, which is 32. That should say 2. So the value of 8 to the power of negative 5 over 3 is 1. So in standard form conversions, what am I doing? Well, I know I need to have my number as a value between 1 and 9.9 times 10 to the power of something. So I turn this into a value between 1 and 9.9. So that's 5.735. And it's being multiplied by 10 to the power of 1, 2, 3, 4, 5, 6. If you ever get stuck in the exam, just start by multiplying it. So like here, I'd start by multiplying it by 10. 5.735 times by 10 is 57.35. Then try doing it by 10 squared. That would give you 573.5. And keep going until you get to your right number. Over here, when you've got a negative, so times 10 to the power of minus 4, well, a negative, let's think about what's happening. So if I had 10 squared, that's 100, 10 to the power of 1, that's 10, 10 to the 0, that's 1. What happens when I go into my negatives? Well, the pattern tells me I'm dividing by 10 each time. So therefore, when I go into my negatives, that means 1 over 10, or you could write that as 0.1. So essentially, what that means is 8.3 times by 1 over 10 to the power of 4. What's 10 to the power of 4? Well, you know, 10 cubed is 1,000, so 10 to the power of 4 must be 10,000. How else could you write that? 1 over 10,000 is the same as 0.1231. So when you've got a negative 4, you can just do a little cheat method where you count how many zeros are before your number. So 1, 2, 3, 4, that's the same as 1 over 10,000. So 8.3 times by 0.00001 would give me 0.123. So I've got 1, 2, 3, 4 zeros, and then I write my number. So conversion and calculation with standard form. Over here, all I need to do is actually physically work it out. So 5.3 times 10 to the power 4, I've got 5. And then I count my numbers, 1, 2, 3, 4. Okay, if you wanted to do it the long way, then obviously just do 5.3 times 10, 10 squared, and so forth and so forth. Otherwise, the cheat way, the quick way, once you've done this enough times, is to count how many digits are after your first letter. So that would be 53,000 plus 4, and then 1, 2, 3, 4, 5. So 417,000. So let's add those two together, 417,000 plus 53,000. What are you left with? 7 plus 3 is 10. 1 plus 5, 6, 7, 4. So altogether, that's 470,000. And you need to write your answer in standard form. So turn that into 4.7 times by 10 to the power of 1, 2, 3, 4, 5. And there you have it. Okay, so a prism and its surface area. So just really quickly, because we don't cover volume, if you were to need to work out the volume of any prism, all you do is work out the area of the cross section, which is the part where, imagine if it was like a cake slice. So imagine whatever the shape is, it was a cake, and if you sliced it, that would be what the cross section is. So the regular shape that goes all the way through your 3D shape. So area of cross section times by length. That's how you'd work out the volume. And here, however, we are being asked to work out the surface area. So when we're working out the surface area, it always helps to just draw out the different types of faces that there are. So you know you've got the front face over here, which is going to be common to the back face over here. So what's the area of that? Well, 8 times 6. Oh, nearly caught me out there. So how do I work out the area of a triangle? It's the base. So area of a triangle is base times the perpendicular height divided by 2. So it's always the perpendicular height. So this would be 7 times 6 divided by 2. 7 times 6 is 42. And 42 divided by 2 is 21. So I know the area of these two shapes here is 21 centimeters squared. So I could say triangle plus triangle equals 42 centimeters squared. Then I might want to work out all of my other faces. So think what is common. So you've got a rectangular base at the bottom. So you have one rectangular base, which is 6 times 5. So that would be 6 times 5 is 30 centimeters squared. And then finally, you've got the two slanted areas of the shape. So this part here, and then also this part here like that. So these are two rectangles, and the area of them is 5 times by 8. So you can use the slant height here because that describes this. So 8 times by 5 would give you 40 centimeters squared, and you've got two lots of them. So you'd say that plus this is 40 centimeters squared. What's the total surface area? You just add all the values up. So 42 plus 40 plus 30 gives you 82 plus 30, which would give you 112 centimeters squared. Now be wary that it's centimeters squared because it's an area. Surface area is the area of all the little parts of the shape. Each face, the area of all of them added up, not cubed, because that's a volume where we're talking about 3 dimensions. Okay, so sector of a circle. Here I am told that ABC is a sector with a radius 6 centimeters and an area of 6 pi. I'm asked to work out the angle of ACB. So what's the formula for the area of a sector? Area of a sector. Well, the formula for the area of a circle is pi times radius squared. And the formula for the area of a sector is whatever the area of the circle is multiplied by the fraction of that circle. So what we say that is theta, which represents the angle, over 360. So I know the area of the sector, I'm told is 6 pi, must be pi r squared, and I'm told that the radius is 6 centimeters. So 6 times 6 is 36, so pi r squared would be 36 pi, and that 36 pi times by theta over 360 is 6 pi. So let's simplify that. 6 pi is the same as 36 pi theta over 360. And what could I do? I could multiply 360 by 6. So 360 times by 6, 6 times 0 is 0, 6 times 6 is 36, 6 times 3 is 18, 19, 20, 21, 2,160. So 2,160 pi, I've just multiplied both sides by 360, is equivalent to 36 pi theta. Now what could I do? Well, I could divide both sides by pi. So 2,160 is equivalent to 36 lots of theta. And then I could divide both sides by 36. So 2,160 divided by 36. Well, I know that 2,160 divided by 360 is 6. So 2,160 divided by 36 would be 60. So where can I write this? So theta must equal 60. And that is the theta is just the name for an angle. So angle ACB equals 60 degrees. Now I'm being asked to calculate the size of the shaded area. So let's get rid of all of this and have a go at working out the shaded area. So the shaded area, I would need to work out the area of the whole sector and then the area of the smaller sector and subtract that. So I know the area of the large sector is 6 pi. Now let's see if I can work out the area of the smaller sector. So area of a sector is pi times radius squared times by theta over 360. Well, I know that the radius of this smaller sector is 3. 3 squared is 9, so that would be 9 pi. I worked out already that this angle here is 60 degrees. So how could I simplify that? Well, area is 9 pi. 60 over 360 would simplify to 6 over 36, which would simplify to a sixth. So the area is 9 pi over 6. You could simplify that if you wanted to. 2 divide both by 3. 3 pi over 2. And there's your area of the smaller sector. So this part here has an area of 1.5 pi. The large area is 6 pi. So the shaded area is going to be 6 pi take 1.5 pi, which is 4.5 pi as our final answer. Okay, so vector geometry. Now the key things we need to remember about vectors is that we always have to follow the direction of the arrow. Well, we don't have to, but if we go in the opposite direction, then it's the negative vector. So LMNP is a trapezium. I know that line LM is M, LP is 3L, MN is a third of LP. Okay, so if I know that MN is a third of LP, then a third of 3L is just L. So I know that MN is just L. The pen's gone a bit big, so let's just make it smaller. What else do I know? I know that B is the midpoint of NP. Okay, so this is the midpoint of NP, which means it's exactly halfway through. So I could figure out what NP is. Now, how could I figure out what NP is? I need to always follow a predetermined route. So how do I get from N to P? Well, I could go along here. So that would be negative L because I'm changing the direction. Along here, which would be negative M because I'm going against the flow of the direction. And along here, which would be plus 3L. So let's simplify that. NP would be 3L take L is 2L take M. So to get from N to P, that is my route. And I know that NB is going to be half of NP. It's halfway there because it's the midpoint. So therefore NB would be a half of 2 is 1 and a half of 1 is half, so L take away half M. That's what the root NB is. And therefore also BP would be L take half M because it's the same. So I am asked to work out the vector AB. So how can I get, let's just get rid of this, from A to B? Well, I can either go along here or I could go along here. So what do I want to do? Let's just have a think. Which would be easier? So I know that A is the point such that LA to AP is 1 to 2. So I know that 3L is split in the ratio 1 part to 2 parts. So therefore, LA must be a third of 3L, which is just L. So LA is just L. And AP must be 2L. So there's a few ways I could do this. I could either go along the route of AP plus PB, or I could go down the route of AL plus LM plus MN plus NB. Which way to go? Let's just go along this way. So A to P plus P to B would give me A to B. The route from A to B, I could go from A to P and P to B. I've already said that A to P is 2L. And P to B, well, I know that B to P is L take 2M. So P to B would be the reverse direction. So that would be a half M take L. So I've got a half M take L, which equals, so 2L take L is L plus a half M. So therefore vector AB is L plus a half M. Okay, so here we've got a combination of ratio and some circle theorems. Remember, just because things aren't mentioned in the advanced materials doesn't mean they're not going to come up. So here we are shown a cyclic quadrilateral. Now, what do we know about cyclic quadrilaterals? Well, hopefully you know that in a cyclic quadrilateral, so anything that is kind of like encompassed by a circle, you know that opposite angles sum to make 180 degrees. So we need to use that information. So opposite angles sum to 180. In a cyclic quadrilateral. So therefore we know that A plus 30 plus C must equal 180, and we know that A plus B must equal 180. Now we know that the ratio of A to B is 1 to 3. So the ratio of A to B is 1 to 3, and we also know that A plus B makes 180. So therefore we need to split 180 into the ratio 1 to 3. So that's 1 part to 3 parts. So in total, that's 4 parts. So 180 divided by 4. 4 is into 18, go 4, remainder 20, remainder 2. So 4 is into 20, go 5. So each little part is 45 degrees. So therefore, angle A is 45 degrees. 45 degrees over here. And angle B is 45 times 3, which is 135 degrees. So, oh, there's thunder outside. Okay, so we figured that out. We know that A, we figured out, is 45 degrees. So 45 plus 30 is 75. So this angle here is going to be 75. And therefore, 180 takes 75 gives me 105 degrees. Therefore, C is 105 degrees. And yep. Okay, so here we've got a Venn diagram question, and I've spiced it up a little by incorporating some algebra into it. So we are told that the Venn diagram shows information about the types of instruments that students play. Over here we have the universal set, so that means in total everything in the Venn diagram must sum to 60. And P stands for the piano, V stands for violin. So we are told that a student is chosen at random. They can play the piano. So they would be in this part of the Venn diagram. Work out the probability that they can also play the violin. Okay, on the sum of it looks like quite a simple question, but it's actually quite nasty. So we are told that there are 60 students in total. And we know that each part of the Venn diagram must sum to make 60. So the first thing we need to do is set ourselves up a little equation. So we know that x take 8, so this part here, x take 8 plus x plus x brackets x take 7 plus all of this, which would sum to 18, must equal 60. Okay, so I've accounted for each part of my Venn diagram and I know that it must make 60. So next step, I can simplify it. So I've got x plus x, which gives me 2x. Let's expand this first. So you've got x, 2x, take 8, plus x squared, take 7x, plus 18 equals 60. Okay, let's simplify it even further. 2x, take 7x gives you minus 5x. So let's start with the x squared. X squared minus 5x minus 8 plus 18 is positive 10. And that must equal 60. Okay, so you've got your quadratic. Now, whenever you have a quadratic, you should know by now, hopefully, that you need to solve it. So make it equal to 0 and then factorize. So let's take 60 from both sides. You've got x squared, take 5x, take 50 equals 0. So let's factorize it. Well, 50. Numbers that multiply to make 50, 5 and 10. And how can I combine them to make negative 5? So 10, take 5. No, negative 10 plus 5. So x take 10, x plus 5 equals 0. So therefore x is 10 or x is negative 5. Now we're talking about a real life context, so you're not going to use a negative value. You can't have negative 5 people that play the violin and piano. So x is 10. So I can substitute that in to work out all of my probabilities. So I know people that play the violin and piano is 10. People that play the violin is 10 take 8, which is 2. So in this section here, we've got 2 and here it's 10. So violin is 12 people in total and piano must be, so 10 times by 10 take 7 is 3. So that's 30 plus 10 is 40. So in total, 40 people play the piano. Now this is important because it says a student is chosen at random, they can play the piano. So therefore your probability is going to be out of the amount of people who can play the piano, which is 40. Work out the probability that they can also play the violin. Well, that's your probability section in here. How many people can play the violin and the piano? 10. So your probability would be 10 out of 40, which you could simplify to make a quarter. So it is tricky, but only tricky because you have to factorize and solve your quadratic. Otherwise, it works exactly how any other Venn diagram would work, where your universal set tells you what is inside, and the cross section is what is for both. So I've got a linear sequence and I'm being asked to work out the nth term. So that's the rule for the sequence. So I need to find an expression in terms of n for the nth term of this sequence. So I've got -4, -1, 2, 5, 8. The first thing I always do is try to work out what the difference is. It's a linear sequence, so there should be it's an arithmetic sequence, so common difference. To get from -4 to -1, you add 3. To get from -1 to 2, you add 3. 2 to 5, you add 3. 5 to 8, you add 3. Okay, so that means that my sequence is going up in the 3 times tables. So I'm going to say the first part is going to be 3n because it's a 3 times table. It's 3 times whatever is going to give you, like, say this is 1, 2, 3, 4, 5. The 6th term, if I did 3 times 6, that would be 18 in the normal 3 times tables. But what I want to do is write out the normal 3 times tables above. So that would be 3, 6, 9, 12, 15, and then obviously, like I said, this one would be 18. So I know the sequence is going up in the 3 times tables, and if it was the 3 times tables, this is what the sequence would be. However, it has shifted. It's either shifted up or down. In this case, it's shifted down. So how do you get from 3 to -4? You subtract 7. 6 to -1, you subtract 7. 9 to 2, you subtract 7. So it's basically the 3 times tables, but 7 less than that. So that's it. That's how I'd find the nth term of. So quadratic sequences are a little bit harder, but they follow rules. So let's just have a look at what's happening. I'm told that the first two terms of a quadratic sequence are 7 and 16, and then I'm given some further information about the sequence. So I know that the first difference is 9, then 15, then something, and the second difference is 6. And I need to work out the nth term of this quadratic sequence. Okay, so what I'm going to do is use the information they've given me to work out the little missing steps. So plus 6 plus 6. So what's 15 plus 6? It's 21. So I know, sorry, that the next step is going to be, the next difference is going to be 21 over here. I'm working backwards. What's 16 plus 15? 31. And then what's 31 plus 21? That would be 52. Okay, so the sequence is 7, 16, 31, 52. And I know that the second term difference is 6. So for any quadratic, what I do is I work out the second term difference and then I halve that. So let's just do some, there's not much space here really, but let's just do what we can. So quadratic sequences means, unlike linear sequences where they go up in the 3 times tables or the 5 times tables, it's going to be going up in the x squared times tables. So what are the squared numbers? Or let's call it n, because it's asked us to work out the nth term. So the square numbers are 1, 4, 9, 16, 25, 36. Okay, but it's not just going up in the square numbers. It might be going up in something more than just the square numbers. And in this case, you figure out what that is by working out the second difference and halving it. So it's going to be going up in the 3n squared times tables. So all I do, and if the second difference was 4, then it would be the 2n squared times tables. And if it was going up in 2's, then it would just be the n squared times tables. So 3n squared, 1 times 3 is 3, 4 times 3 is 12, 9 times 3 is 27, 16 times 3 is 48, 25 times 3 is 75. So I know that my sequence is going up in the 3n squared, so let's just write it up here. So that would be 3, 12, 27, 48, 75. It's going up in the 3n squared times tables. However, my sequence, oh, that's gone really big. My sequence is not exactly that. It is 7, 16, 31, 52. So the first part of my sequence, just like with the previous one, it's going up in the 3n squared times tables, but it's the 3n squared times tables, and there's a little difference. So it's the 3n squared times tables, but 4 more over here, 4 more over here, 4 more over here. So it's the 3n squared times tables plus 4. And that's how I would work out the nth term of this quadratic. So for your quadratics, work out what the second difference is, because the first difference is never going to be the same. If it was, it would be a linear equation, a linear sequence, and then compare half of the second difference, so halve it, half of the second difference multiplied by the square numbers, and then compare that to your sequence. If this is confusing, drop a comment and I'll make a video on quadratic sequences to explain it in a little. Now here we've got finding the original fraction. So we're told that 3/5 of a number is 45. Work out the number. So if I've got my number and it's been split into 5 parts, because that's what I've been told, 1, 2, 3, 4, 5. 3/5 of that is 45. So I know 3/5 of this number is 45. So if I did 45 divided by 3, I could figure out how much 1 part is. And 45 divided by 3 is 15. So each part of this fraction, each fifth, or I could have done it like the fractional way if you don't like the picture method. So 1/5 must be 15. To work out the whole number, I need to work out 5/5. So either multiply 15 by 5 or I could do it like this in the little picture, because pictures are just a lot more fun. So 45 plus 30 would give you 75. So the original number is 75. In this question, I have been given a circle with a cyclic quadrilateral, and the whole weird shape forms a large triangle. So always try and visualize to yourself what shapes are actually formed, because that helps you later on. So first of all, I'm told that A, B, D, E is a cyclic quadrilateral, and that's important because if it's a cyclic quadrilateral, I can use the circle theorems. Now, in order for something to be a cyclic quadrilateral, it just means that each of its vertices of the quadrilateral need to touch the circumference of the circle. So if they hadn't told you that, you could have figured it out yourself by just thinking to yourself, okay, each of the vertices touch the circumference of the circle. So that's an important thing that we can use later. I know that ABC and EDC are straight lines, and I'm told that angle DBC is 60 degrees. So let's first have a look at what we can work out from here. So I know that this is a straight line. Therefore, I could work out this angle here. So angle ABD must equal 120 degrees as angles on a straight line sum to 180 degrees. Now, because this is a circle theorem question, anything that has angles or circle theorems, you're going to want to show all of your working and all of your reasoning. So all of the angle rules that you know. The only way you could have figured out that this angle is 120 is by knowing that angles on a straight line add up to 180 degrees. So just write it down. The next thing we can do is we were told that this is a cyclic quadrilateral. Now, in a cyclic quadrilateral, opposite angles sum to 180 degrees. So in a cyclic quadrilateral, opposite angles sum to 180. So I could figure out what this angle here is. Therefore, angle AED must equal 60 degrees. So I know that angle is 60 degrees. And then what other information have I been given? Well, I'm told that the size of angle EAB, so this angle here, to the size of angle BCD is 2 to 1. So whatever the size of angle BCD is, that was X, this would be 2X. So I could label that accordingly. This is X and this is 2X. Now, the next part, so you've done like all of your working out from all of the information that you've been given. And this is the bit that catches most people out. You just want to try and visualize to yourself, okay, so I've sort of worked out everything I can within the cyclic quadrilateral. I've done my straight lines. I can't see anything further that I can do. So let's just have a look at what happens if I just zoom out and take a bigger picture. I know that there's a triangle that's formed. So I have this triangle over here. That's got the angle X, which is the angle I'm trying to work out. I know this is 2X, and I know that this is 60 degrees. So you then have an angle, and we know that angles in a triangle sum to 180. So that would be our next rule. So angles in a triangle sum to 180 degrees. You can form an equation using the ratio parts that you've been given. So X plus 2X plus 60 degrees must equal 180. Therefore, 3X plus 60 equals 180. Therefore, 3X must equal 120 and X must equal 40 degrees. So the last part, and the bit that kind of catches most people out, is just zoom out and think to yourself, okay, I've got a cyclic quadrilateral, but how can I look at all of the other lines? Oh, that's a giant triangle. So in this question, I've got one of the trickier kind of a ratio questions. So let's have a look at what's going on. I'm told that there are 4 boxes on the shelf, A, B, C, and D. And the total weight of A and B put together is 3 times the total weight of C and D put together. So I know that the weight of A and B must be 3 lots of the weight of C and D. So I could just write that algebraically, or I could just leave it as 3 to 1. It doesn't really matter. So I know that whatever the weight of A plus B added together is, it must be 3 times the weight of C and D. So I need to keep splitting it into that ratio. Now the next piece of information I'm given is the weight of A is 2/3 the weight of B. So out of this ratio here, I know that whatever the weight of B is, so we could call B X, the weight of A is going to be 2/3 of that. So 2/3 of X plus X, which I could actually write as 3/3, just so that you maybe see what's going on, because X is a whole thing, value. Whatever B is the value that I'm relating to. A is going to be 2/3 of it. So if B was 30, A would be 20. But I'm just calling it X because I don't know the value. You can substitute values if you want to, as long as you keep it constant. So I know that 2/3 of X plus 3/3 of X, or a whole X, must equate to 3. So therefore 5/3 X must equal 3. And how could I figure out what X is? Well, I divide both sides by 3. So 3 divided by 5/3 gives me 9/5. Okay, so either, I'm trying to think, I'll leave it in fraction form. So I know that if X is 9/5, then I'll write it in all forms actually. The value of A, the value of B, the value of B would be 9/5 or 1.8. And then times that by 2/3 to figure out the value of A. That would be 6/5, or in decimal form 1.2. So I figured out what the ratios of A to B must be, and that would be 1.2 to 1.8. So I've just broken that up into 2 parts, 1.2 to 1.8, and that is the ratio of A to B. Now what I want to do is do the same, but with this part here. So I know that the weight of C and D is going to be 1 part of whatever A plus B is. So I know that the weight of C is 75% the weight of D. So therefore 75% I can write as 3/4. So if I give my value of D an algebraic form, so I'm just going to call D X because that's the value that I'm working with that I know as a whole. So if D is X, then C would be 3/4 X. And once again, I could write this as 4/4 X because what's 4/4? That's a whole. So it's the same thing, but just so you see what's going on. So 3/4 X plus 4/4 X must equal to 1. Add them together, 7/4 X must equal to 1. So therefore, how am I going to work out what X is? I'm going to divide both sides by 7/4, which leaves me with 4/7. So therefore, C and D, well, D must equal 4/7, or if I type that into my calculator, 4/7 is probably going to be, yeah, so 0.57142. It's not a nice easy decimal, so I'm going to leave it in fraction form. And then 3/4 of 4/7 is going to give me 3/7. And once again, that's probably going to be a long decimal. So I'm going to choose to keep this in its fractional form. So let's rub this out, and I've got all of my key values here. I know that A to B is 1.2 to 1.8, or I could write it in fractional form, 6/5 to 9/5, and then C to D must be 3/7 and 4/7. So I've got all of my ratios in this form in a way that they relate to each other, because I started by splitting them up into the ratio 3:1. And then using this ratio, I split them up into their A and B and C and D correspondence. So now this is the full ratio. However, it doesn't actually say to simplify it, but we're going to do that anyway. So let's just have a go at seeing what we'd need to do. So A to B to C to D is 6/5 to 9/5 to 3/7 to 4/7. Now, in order to simplify this, I want to turn them all into whole numbers. And what's the best way of turning them into whole numbers? Just multiply by the denominator. So let's start by multiplying the whole ratio by 7. So 6/5 times by 7 is going to give me 42/5. 9/5 times by 7 is going to give me 63/5. And then the reason I've multiplied by 7 is because if I multiply anything by its denominator, or its reciprocal of the denominator, look what happens. So 3 times 7 is 21, divided by 7 ends up with 3. So I basically eliminate the denominator. That's why I multiplied by 7, to get rid of these denominators here. So it'll become 3 to 4. Then what can I do? Well, I can multiply the whole equation by 5, because both of these parts have a denominator of 5. So that would be 42 to 63. 3 times 5 is 15, and 4 times 5 is 20. So that is how you would find the ratio. Now, there are so many different ways that you can do this question. This is just one of the ways. If you still ended up with this ratio, then I'm sure that you'll wait. This question, I'm told that there are only blue counters, red counters, and green counters. And the probability that a counter taken at random from the box will be blue is 0.4. So the probability of blue is 0.4. The ratio of the number of red to green counters is 7 to 8. Samina takes at random a counter from the box. She records its colour and puts the counter back in the box. So there's we don't need to alter the denominators because everything is replaced. And she does this a total of 50 times. Work out an estimate for the number of times she takes a green counter. Okay, so we don't know how many counters there are in total, but we know that whatever red and green sum to must be a probability of 0.6, because probability always sums to 1. So red and green are split in the ratio 7 parts to 8 parts. So we need to think in total, that means there are 15 parts, and we want it to equal 60% or 0.6 or 60 over 100, however you want to work with this. So I know that to turn 15 parts into a percentage, I would multiply it by 4, because that gives me 60 parts in total. And then I can work with the equivalent ratios of the blue. So 7 times by 4 is 24, and 8 times by 4 is 32. So if I were to have these all as a ratio, I know that blue parts would be 40. And so blue to red to green would be like that, because I've made my probability sum to 1. And what do I need to do? She takes at random a counter from the box, records its colour, and I need to work out an estimate for the number of times she takes a green counter. So the probability of a green counter would be 32% or 0.32. And whenever you work out probability, you always do the probability of your chosen thing. So in this case, of your chosen thing happening. In this case, it's a green counter. The probability of getting a green counter is 0.32. And you multiply that by the number of trials, which means the number of times you do something. So in this case, it's 50 times. So we're going to do 0.32 times by 50, which gives me 16. question, I'm told that yesterday it took 5 cleaners 4.5 hours to clean all the rooms in a hotel. So 5 cleaners, it took them 4.5 hours. Today, there is only 3 cleaners, or there are only 3 cleaners to clean all the rooms. So I need to figure out how long it's going to take them. Now, this is inverse proportion, because if you think about it logically, the more people you have there to clean, the quicker you're going to clean it in. The less people you have, the longer it's going to take. So with inverse proportion, what we do to one side, we have to do the inverse to the other. So 5 cleaners, it took them this long. To figure out how long it would take one cleaner, well, there's 5 people doing the same job, so it's going to take them 5 times as long. So what I need to do, how do I get from 5 cleaners to 1? I divide by 5, but in terms of time, I'm going to have to do the inverse, so I'm going to have to times by 5. And if I do 4.5 times by 5, that gives me 22.5 hours. So I know that if just one cleaner was doing the job, it would take them 22.5 hours. So with inverse proportion, it always helps to get it to figure out your total amount of time that it would take one machine or one person or one of whatever thing that they're asking you to do. Now I know that there are 3 cleaners. Okay, so I know that one cleaner, it would take them 22.5 hours. How do I get from 1 to 3? Well, I times by 3. So therefore, I'm going to have to do the inverse on this side. I'm going to divide by 3. Because obviously 3 cleaners are going to make the job faster. So that's why I'm dividing. But it's kind of, some people found it really counterintuitive because we're so used to dealing with direct proportion. So 22.5 divided by 3 gives me 15/2, which is 7.5 hours. So I know it's going to take these 3 cleaners 7.5 hours to clean the hotels. I know that each cleaner is paid £8.20 for each hour or part of an hour they work. That's quite nice. So if they worked for like 2 minutes, they'd get paid for an hour. So therefore, that means that in total, they're going to get paid for 8 hours, because 7 total hours and then 0.5 of an hour counts as part of an hour. So how much will each cleaner be paid today? Well, if a cleaner works 8 hours and they are paid £8.20 per hour, then I just do 8 times by £8.20, which gives me £65.60. Okay, so I've been given 3 inequalities and I've been asked to shade the region that satisfies all of them. So the nice and easy one is this one here. If you ever have a y equals or an x equals, you know they're just going to be straight lines, horizontal or vertical. The y equals line is going to be horizontal, x equals will be vertical, but let's see why. So let's just draw the line y equals 3. That would be where the line crosses the y-axis at 3, because at every single point, the y coordinate is going to be 3. So that coordinate here is 1, 3, 2, 3, 3, 3, so forth. That's why it's called the line y equals 3, because every y coordinate is 3. And just a key thing to remember, if you have a less than or equal to or greater than or equal to, it's going to be a solid line on your grid. If it's less than or greater than, it's going to be a dotted line, just to represent that the inequality is not satisfied by the actual line. It can't be on the actual line. So that's my first line. Then I've got x plus y is greater than 3. So I could just rearrange that to say y must be greater than 3 minus x. And there's a number of ways you can do this. You could do a table of values, and that's absolutely fine. Or you could just pick a few points to speed up the process. So I know that y is 3 minus x. So if I said that x is 3, 3 minus 3 is 0. So I know that's going to be a point here. If I said that x is 1, y is 3 take away 1, which is 2. If I said that x is minus 1, 3 minus minus 1 is 4. So that's going to be my coordinate. And if I said x is minus 3, 3 minus minus 3 is 6. So I just picked some random coordinates. But if you feel more comfortable, you can do a table of values, or you can just read it off the line. I'm just going to do another one. So let's say x is 5, 3 minus 5 is minus 2. Then you join, okay, and this line is a dotted line. So you join your line together with a ruler, but you just do a dotted line like that. Okay, so that is going to be the line y is greater than 3 minus x. Now I've just drawn them. I haven't said anything about them yet, but we'll do that at the end. And the final line is y is greater than or equal to 2x minus 2. So imagine it's the line y equals 2x minus 2. The quickest way is to just say, okay, what's the value of y when x is 0? So when x is 0, y is 0 minus 2. I mean, you know that anyway, because the y-intercept is minus 2. Let's do the same for when y is 0. So when y is 0, 2x must be equal to 2, so x must be 1. So when y is 0, x is 1. And then what we can do is just pick another coordinate, so let's say 3. So y must be equal to 6 minus 2, which is 4, so that would be the coordinate 3, 4. If this is confusing, this is just like the quick way to do this. Just do a table of values like this and pick a bunch of coordinates, but this is just a slightly quicker way. And then I've got 3 values. I could join them up, but let's just do another one. So if x is 2, y is 4 minus 2, which is 2. So you've got your line, and it's a solid line, so we join it up. Oh, that's not a very straight line. So we join it up as straight as we can. Now, this is where I want to think about what the inequalities mean. So for this line, y is greater than the line 2x minus 2. So all of the y coordinates must be above. Okay, so everything that satisfies this inequality is above the line. Then for this line, y is less than or equal to 3. The y value has to be less than or equal to 3. So it's everything that is below this line. And then for this line here, y is greater than 3 minus x. So the y values have to be above that line. So therefore, everything that intersects would be in this region here. And you label that R. To double check, what you could do is you could pick a point. So like we could pick this point here, let's say 1, 3. So 1, 3, when x is 1, y is 3. And let's see if that works. Does that satisfy the inequality y is less than or equal to 3? Yes. 1 plus 3 is greater than 3. Yep, that works. 3 is greater than or equal to 2, take away 2. Yes, 3 is greater than 0. So it satisfies all of the inequalities, and that's how you can double check. Okay, so here I've been given 2 triangles, ABC and BCD, and some values of the angles and some values of some lengths. And I need to find the length of CD. So as it stands, I don't have enough information to just use triangle BCD. So that means I'm likely going to have to use triangle ABC to figure out some things, most likely this side over here. So let's have a look at what I've been given. I've been given an angle here, an angle there. And because I've been given 2 angles, what I can do, just to start me off, is just figure out what the missing angle over here must be. Because angles in a triangle sum to 180. So 180, take away 32, take away 28, gives me 120 degrees. So I know that this angle over here is 120 degrees. Now I've been given, I know 3 angles and I know a side, and I'm trying to work out BC. So I'm trying to work out another side. So the best thing to use would be the sine rule, where A over sine A is equal to B over sine B. Is also equal to C over sine C, but you don't need to use all 3. It just means that they're in the same ratio. So let's start by labeling it. I could label this as big A, this is little a. Remember, the big letter represents the angle and the little letter represents the side. So that would be A and A. And then I'm trying to figure out, this side here. So this side here, so its opposite angle would be over here. And having just told you what to do, I've just done it wrong. But there we go. So now I can use that to substitute into the sine rule. So A, 25.2 over sine A, so 120, must be equal to BC over sine 32. So all I do, I've got my equivalent fractions. I need to figure out what BC is. So what I can do is just multiply both sides by sine 32. And that will tell me what the length of BC is. So 25.2 over sine 120. Remember to close your bracket when you're typing in the angle, equals times by sine 32 is 15.4198311. Okay, so now I know the length of that side. Okay, so I know the length of this side, 15.41. I know the length of this side, so I have two sides and one angle, and I'm trying to work out a third side. So if you know that if three sides are involved, then you're going to be using the cosine rule. And let's just recap as to what it is. So the cosine rule is a squared equals b squared plus c squared minus, my brain's just stopped working, minus 2bc cos a. Okay, it's also on your formula sheet, so you don't need to worry about memorizing this. Remember, the little letters represent the sides and the big letter represents the angle. And all that matters is that the side that you're trying to find is opposite the angle that has been given. So this is the side I'm trying to find. This is the angle that has been given. So that's all good. And I know the values of the other two sides. So a squared, I can rename that to BCD squared, just so it's clear what I'm doing, is b squared. And it doesn't matter which side's a, which side's b and c, because you're using the same things for them. So let's just say 19.2 squared plus 15.41, and I'm going to save that as an answer, squared, take away 2 times 15.41 times by 19.2 times by cos 41. So let's simplify that. So answer squared plus 19.2 squared gives me 606.4111913. I just like to be accurate. And then we can do everything in the bracket. So 2 times by 15.41, and I've written it all out, so I'm just going to write it in again. 198311 times by 19.2 times by cos 41 gives me 446.8797795. So I'm going to just do that subtraction. 606.4111913 take away answer gives me, so I know that CD squared must be 159.5314118. So CD is the square root of this. So CD is the square root of answer, which is 12.63057, and it says to 2 decimal places. So CD equals 12.63. Okay, so here we've got quite a tricky question involving bearings. So the first few things that we need to really bear in mind when dealing with bearings is that we always start from due north. So all bearings, you're always going to see this little due north sign, and we always start measuring it from north, so that when we're communicating with bearings, we know like in what relation it is to. So always start from due north. You always go clockwise. You always write them as 3 digits. So if the angle you found was, let's say, 52 degrees, you would write that as 0352. And the last thing is that you always start from where it says from. So these are the key things that we need to know. If bearings are a little bit confusing, then just watch the full video that I've done on bearings, where I explain through it a little bit more slowly. Now, sometimes it's not just going to be bearings you're going to need to use, it's going to be trigonometry as well. And if it's something that looks like this, likely that's going to be the case. So the cool thing about bearings is that they are always, like I said, you always start from due north. So let's just imagine it's a simple bearing where you've got a ship here and a port here. Now what we do is we have our two bearings, like literally this point here is where the ship is, this point here is where P is. And what we can do is draw a bearing going up north. So draw our little up north sign and just draw a line connecting the two bearings. Now, if I wanted to work out the bearing of the ship from the port, what I do is I start from due north, I go clockwise until the line, and this would be the bearing. So let's just say that's, I don't know, 280 degrees. So the bearing of the ship from the port would be 280. However, if I wanted to work out the bearing of the port from the ship, then I'd start from here and I'd go clockwise. So it would be this bearing here. So that's just something to bear in mind. But let's apply it to this question here. So I've got three towns, Branton, Cordon and Dorringford. And I know that Branton is 7 kilometres from Cordon on a bearing of 41 degrees. And that Cordon is 9.5 kilometres away from Dorringford on a bearing of 160 degrees. So that's all the information that I know. Now, using bearings, it's always going to be really helpful if you just use your knowledge of parallel lines first, especially if you don't know where to start. So over here, I've got my due north sign. Over here, I've got another due north sign. Therefore, these two lines are parallel because they are both just straight up north. So using parallel lines, I know that when angles are on the inside of the parallel lines, they are called co-interior angles, and they sum to 180 degrees. So therefore I can figure out what this angle here is by doing 180, take away 41, which is 139 degrees. So I've figured out just that little bit of angle there. When you get a complicated question like this, you're always just going to want to problem find like a little hunt for anything that you can get. You don't, well, I never start where it's asking me to. I always think, what can I figure out from the question already? What else can I do? Well, I know that this over here is a point, and I know that angles are point sum to 360. So I could figure out what that angle there is by doing 360. Take 139, take 160, which leaves me with 61 degrees. So these are just the easy angles that I can find out before I've even looked at the rest of the question. Now, I want to find the bearing of Dorringford from Branton. Now, remember, that's the key word that we need to look out for. So we start from where it says from. So first things first is I want to draw a straight line from bearing what was it called, Branton to Dorringford. So essentially, I'm just going to get rid of all of this. Essentially, what is happening is this is the bearing that I need to work out. So I'll just draw it separately here. So this is Branton and this is Dorringford. Okay, and this is what it would look like if it was just one bearing. And I need to work out this angle here, which would be all of this. So in order to do that, I have formed a triangle here, and I know this angle here is 61 degrees because it's over here. I know this side here is 7 and this side here is 9.5. So I am going to have to use some advanced trigonometry to help me work the next steps out. So I've got two sides, one angle, and the trick is to, when you're using the sine rule, you want to have two sides and their corresponding angles, one of which you want to find out. But essentially you want two sides and two angles, and one of them can be missing, but it needs to be corresponding. Whereas here, if I just labelled this triangle, let's label this big A and this little a, and this would be little b. So this here would be big B, this C, and this would be big C. I don't have the corresponding angles for anything apart from A. So if you only have one angle and its corresponding side, then you're most likely going to use the cosine rule. So the cosine rule is a squared equals b squared plus c squared minus 2bc cos A. It's also on your formula sheet though, so you don't need to worry about memorising it. And all this means is a little letter, it represents a side, and a big letter, it represents an angle. And you can label your triangle however you want. A, B, and C, if they've labelled the triangle A, B, and C, but you want a different angle to be A, that's absolutely fine. Cross out what they've written and you relabel it the way you want to. So I know that B is 9.5, C is 7, and big A is 61. So to work out the length of this side here, which is what my bearing of BD is on, I would do 9.5 squared plus 7 squared, take away 2 times by 7 times by 9.5 times by cos 61. So A squared is going to be, and I always tend to do the calculation in two parts, so I do 9.5 squared plus 7 squared, just because it minimises accidental errors on the calculator. So that's 139.25, and then 2 times 7 times 9.5 times cos 61 is 64.4796, but I don't need to write it all out because it's memorised on my calculator. So A squared is going to be 139.25. Oops, I'm supposed to be typing that into my calculator. 139.25, take away answer. So your calculator automatically memorises the last thing that is that it calculated, so you can just use that as a shortcut. So take away answer is 74.7732 blah 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 blah, and A is going to be the square root of this. So A is square root of answer, which is 8.646. So I'll just rub this out so that there's room for it. Actually, I'm going to write it out here just in case I need the full for later. So 8.646983318. Okay, so this is the length of this side here. Now, once again, I've got the same triangle, and the thing is, because it's a tricky question, and a question similar to this appeared as like the last question on one of the papers, so this is not an easy question, but I just wanted to throw it in there because it's important. So let's have a look at what we know now. We know that this is 61, we know this is 8.64, we know that this is 9.5, and that this is 7. And this here, this angle here, is the angle that I'm after, because if I know what that is, I can work out what the bearing is. So let's label it again. We can keep this as it was. I can't remember if this was little b or big B, but it doesn't matter. So, and with the sine rule, there are two options. You can either write A over sine A equals B over sine B, or it can be sine A over A equals sine B over B. Now this option, and once again these are on your formula sheet, is best if you are finding a side, and this option is best if you are finding an angle. And the reason for that is because you essentially want whatever you're finding to be the numerator of the fraction, because then it's less rearranging. But on it, you can actually use either, it's just a bit more rearranging. But it's just a helpful hint to know. So I'm trying to work out the angle, so I'm going to use the second version where the angle is on top. So sine A over A is equal to, I'm supposed to be substituting, so sine 61 over 8.64 is equal to sine B, which I don't know, it's this here, over 9.5. So therefore, if I multiply both sides by 9.5, sine B is going to be equal to, so sine 61 over 8.64 times by 9.5 is 0.96167, and so forth. Remember, I'm going to save this as my answer, so I don't need to write everything down. So therefore, the value of angle B is going to be the inverse. So I press shift, sine, and then answer. So shift, sine, answer, and that tells me that angle B is 74.47 0.0865, so forth, degrees. So I need to work out this bearing of Dorringford from Branton, strange names. So therefore it's going to be this angle here. Remember, you start from due north, you go clockwise until you reach the line, and your bearing is going to have to be 3 digits. So 74.0865 plus 41 is 115. 0.086506, that's the angle. Now it's saying give your bearing to 1 decimal place, which I will do just now. So I know that this angle here is 115.086506, so therefore the bearing to 1 decimal place is going to be 115.1 degrees. And yes, a slightly tricky one, but basically if you have something that looks complicated and looks like you could form a triangle, you're going to use the sine and the cosine rule. So just see what you can substitute, see what you can figure out, and you will get somewhere. Okay, so here I've been given a cuboid, and so I know that I'm going to be using 3D trigonometry, 3D Pythagoras, and don't be scared by that. All it is I'm going to be using multiple versions of Pythagoras and trigonometry, so do it bit by bit, step by step to get to the next point. So let's start with what I know. I know that DC has a length of 8 centimeters. I'm then told that the ratio of DE to DC is 3:2. So if DC is 8, then what have I done to get from 2 to 8? I've times by 4. So this I'm going to have to times by 4 as well. So therefore DE must be 12 centimeters. And that means that all of these sides as well are going to be 12 centimeters. Similarly, all of these sides are going to be 8 centimeters, just in case I need that for later. I'm told the angle ACB is 37. Okay, so then I can form a triangle over here. ACB is 37, so this angle here is 37 degrees. And then what I can do, when you form a triangle on a 3D trigonometry kind of question, always just draw out the 2D version of it. So over here is going to be the right angle because that's where the 2 corners meet. So you've got this triangle here, where I know that this length is going to be 8 centimeters. I don't know this length, but I know that this triangle here is, this angle rather, is 37 degrees. So I need to then find the size of the angle between CF and the plane ABCD. The plane just means like the flat bit. So CF is this line here and the plane ABCD. Okay, so then I can draw this triangle here and form a right angle there. So if you visualize what you could do, you've got your right angle triangle here. It's this triangle here. It's a 3D triangle. If you can kind of visualize it, it's a little bit hard trying to visualize them. And I know that I need to work out this angle here. So is there anything that is common to the triangle that I've just drawn and this triangle here? Well, they both have AC as one of their lines. So what I know I could do is figure out what AC must be using my first triangle. So let's just write out SOHCAHTOA because that's always just a great way to start the day. It avoids so many silly mistakes that happen just due to rushing. So I've got my angle here. Therefore, this is going to be the hypotenuse, this is the adjacent, and this would be the opposite. Now I want to find the hypotenuse and I've been given the opposite. So O and H. So I know I'm going to use sine. So sine theta, so sine 37 is equal to the opposite, 8 over the hypotenuse. So now there's a little trick. We can just switch to subjects, or you can do it properly where you say H sine 37 equals 8 and then divide it. I'm just going to switch them just for speed of time. So 8 over sine 37. So I know that AC is going to be 8 over sine 37, which is 13.2931213. So I know that this length here is 13.29. What else do I know? Well, I know that this side here is 12, and therefore I've been given, I know two sides and I need to figure out the angle. So once again, I'm going to use SOHCAHTOA. Let's label the triangle. What have I been given? This is the given angle, so this is going to be the adjacent. This is going to be opposite. So I'm using opposite and adjacent OA. So tan theta, the angle I'm trying to work out, is going to be the opposite, 12 over the adjacent, 13.29. And I'm just going to save that as an answer. So therefore the angle is going to be the inverse. So shift, tan, and then your fraction, 12 over 13.299. So I'm going to press shift, tan, and then 12 over answer gives me 42.0732, and to one decimal place would be 42.0. Remember, even if it's a 0, if it says to one decimal place, make sure you write one decimal place, just in case, because sometimes that could cost you a mark. Also, I'm very tired, so I rounded that wrong. Obviously, to one decimal place, that would round to 42.1. Okay, so in this question, I am told that the equation, the cubic equation, has a solution between x is 0 and x is 1. So all that means is that the cubic graph must be crossing the axes between x is 0 and x is 1. And the way to prove that is, well, over here, x is 0. Sorry, y is 0. And anything above that, y is going to be positive. Anything below that, y is going to be negative. So if you can prove that between these two values, when x is 0 and x is 1, the y changes from a positive to a negative, then you've proved that there must be a solution between there. So what we do is we substitute the values in. So first of all, we'll put 0 cubed minus 3 times 0 plus 1 equals, and then 0 cubed is 0, 3 times 0 is 0, so that equals 1. So what we're hoping for is that the next part is a negative. So 1 cubed, take away 3 times 1, plus 1 equals, well, 1 cubed is 1. 1 take away 3 is minus 2. Minus 2 plus 1 is negative 1. So I know that the y values are going to be negative 1 and 1. So therefore, to show that there is a solution, you say there is a change in sign from 1 to negative 1, showing there must be a solution. Okay, for the next part, it's just a simple rearranging. Now, you need to show that the equation x cubed minus 3x plus 1 can be rearranged to give the equation they want. So let's have a go. So x cubed minus 3x, I'm just going to subtract 1 from the get-go, is minus 1. Don't panic if you see a negative, because there's a trick we can use at the very end. Then I know that they want to have an x squared, so I'm going to need to factorize that to get x out. So x squared minus 3 is going to be equal to minus 1. If I divide both sides by x squared minus 3, I'm left with minus 1 over x squared minus 3. Okay, so whenever we've got something like this, we never want to have a negative as our numerator. We just want to clean it up a bit. So if we multiply everything by negative 1, remember, if you multiply a fraction by the same value with its numerator and its denominator, it keeps it in the same proportion. So we've just fiddled with it a little bit, but it's the same fraction. Like if you had 3 over 6 and you times it by negative 2, that would be negative 6 over negative 12, but a negative divided by a negative is a positive, so you'd end up with the same value. 3/6 is a half, negative 6 divided by negative 12 is also going to be a half. So therefore, if we multiply the numerator and the denominator by negative 1, we clean it up a little bit. So minus 1 times 1 is 1. And x squared times by negative 1 would be negative x squared, and negative 3 times by 1 would be positive 3. And then we just rearrange it to be 1 over 3 minus x squared. So that one Slightly tricky bit at the end, but remember the little trick, multiply both numerator and denominator by -1, and you've cleaned it up. Okay, so for the next part, I am told to, starting with 0.5, use the iteration formula. So that's what I literally just rearranged to find an estimate for the solution of x cubed minus 3x plus 1. So x0 is 0.5, and I'm going to be plugging that into this formula. Remember, all this means is the original term, and all this means is the next term. So iteration is literally the formula that you use to work out the next term using the value of the previous term. So let's start with 0.5. So when you're using an iteration formula and it's a calculator, what you can do, type the first value in. So I'm going to press 0.5 equals, and then I'm going to write the fraction. So it's 1 over 3 take away 0.5 squared. I'm just putting 0.5 in, substitute it into this because xn, that's the original value, so that's going to be 0.5. So I'll write this into my calculator. I press equals, and that, annoyingly, these calculators, please, if someone has any influence, bring back the SD button. It's very frustrating. So 0.36 recurring. So is it recurring or? Either way, it doesn't matter, because what I'm going to do is, now that I've pressed equals, I'm going to go back using my arrow method and delete that, and then press answer, and then press equals. And that will tell me what the next term is. If this is too confusing, just do it bit by bit and substitute each value in. So that would be 0.34870,317. And now, because I've done it 3 times, if I just press equals, it automatically works out the next term for me. So x3 would be 0.3474144,945. x4 would be, let's press equals, okay, 0.34730,625. Press equals again, is 0.3472971. So what you can see, and this is the cool thing about iteration, each time we're going to get closer and closer and closer to the solution. So what you want to do is get to a part where some of your solutions round to the same thing. So after the third term, we can see that all of my values are going to round to 0.347. So in this case, it hasn't told you to use the iteration formula twice. So you just keep going until you find that pattern. So you're going to say x is 0.347, and that is to 3 decimal places. Because to 3 decimal places, for all of these values, it rounds to 0.347. So here we've got an upper and lower bounds question, and if this is the kind of thing that you hate and you get confused by, I'm just going to show you what you can do if you're like, I'm going to leave this question. So I'm going to show you what not to do and just literally how to get some marks, even if you hate these kinds of questions. So the first thing is you want to actually just consider the bounds. And I know that everyone can do that because it's just thinking about rounding. So a dog race is measured to have a distance of 2.8 kilometers, correct to the nearest 0.1 kilometers. Okay, so it's 2.8 kilometers, correct to the nearest 0.1 kilometers. So all we do is we say, okay, what is the 0.1 kilometers surrounding 2.8, i.e. to 0.1 kilometers, in this case, it's 1 decimal place. So it's literally, what are the decimal places surrounding 2.8? That would be 2.9 and 2.7. Now the bounds, that would be the midpoint, okay? So the minimum value, it could be, the lower bound would be 2.75 and the upper bound would be 2.85. Now there's a lot of debate, and personally I think it should be 2.849 recurring, but just for simplicity, we acknowledge that if it was an error interval, it would be 2.75 is less than or equal to x, which is less than 2.85. But just so that, for whatever reason, we just say with bounds, essentially it's the midpoint. So that's the upper bound for the distance. Okay, So everyone can work out the upper bound and the lower bound. All you do is you write the thing, and then whatever it's saying, so it's saying to the nearest 0.1, literally write one decimal place on the right, one on the left, and then you just find the midpoint. Then let's do the same for the speed. Now, okay, it is a little bit tricky because it's got like seconds and all of that, but 5 minutes, 45 seconds, correct to the nearest second. All we need to do is consider the seconds. So 45 seconds to the nearest second. What are the seconds surrounding 45 seconds? That would be 46 and 44. So halfway is the upper and the lower bound. So that would be 44.5 seconds and 45.5 seconds. So the lower bound for time would be 5 mins and 44.5 seconds, and the upper bound would be 5 minutes and 45.5 seconds. So that is for time. Now, this is a tricky question because it's just involving a lot of calculations, but hopefully the minimum that we can get is the upper and the lower bounds, and that's marks. You're just sweeping them up, okay? So I'm told that shadows, okay, so basically I haven't even read out the question. Essentially, a dog race is measured to have a distance of 2.8 kilometers, correct to the nearest 0.1 kilometers. So the distance is roughly 2.8 kilometers. The time is 5 minutes 45 seconds, correct to the nearest second. I've established my upper and my lower bounds, and now I need to work out the speed to a suitable degree of accuracy by considering bounds. Now, whenever you see this question, and if you, obviously this is quite last minute, so what I'm going to tell you to do, if you have the time, just work out each possibility. So for instance, in this case, how do you work out speed? Speed is distance over time. So you're going to have 4 answers. So you're going to have lower bound of distance divided by lower bound of time. You're going to have lower bound of distance divided by upper bound of time. Then you're going to have upper bound of distance divided by lower bound of time, and upper bound of distance divided by upper bound of time. So essentially you're matching each bound to each other. So there's a combination that includes all of them, and that will mean there's 4 combinations. So that is the worst case scenario, because all you're doing then is just substituting values in, and then you're going to get some answers, and then you're going to figure them out. But that is the worst case scenario, and let's actually read the question because I think it actually wants more from us. So the key thing here is that it said speed in this race is something kilometers per hour. Now, his time is in seconds, so it's already kilometers, but it's kilometers per hour that is needed. So I know that 5 minutes is 5 times 60 seconds, because there are 60 seconds in a minute. So 5 times 60 is 300. Okay, so first thing I'm going to do is turn my time into purely seconds. So the lower bound of time is going to be 344.5 seconds. And the upper bound of time is therefore going to be 345.5 seconds. Now, what I'm going to do, because I need to convert this into hours, 1 hour is 3,600 seconds. So therefore, to get from seconds to hours, you divide by 3,600. So 344.5 divided by 3,600 equals, oh, this is nasty, but it's a calculator paper, so that's fine. So the lower bound of time is actually, I'm just going to write it up here because it's long. So the lower bound of time is 0.095694 recurring. The upper bound of time is going to be 345.5 divided by 3,600, which is 0.095972 recurring. Okay, so that is my time in hours. Whenever I'm dealing with speed, generally you're going to have to deal with your time as a unit of an hour. Normally it's minutes to hours, but now it's minutes and seconds to hours, but that's still fine. So what to do next? Right, so I know that is the time, I know the distance, so let's go back, and I know that speed equals distance divided by time. Now, either you do what I tell you to, which is you put all four options together, because then you can see, you just have all four options and you don't have to do anything confusing, or you think about how could you get the biggest variation. So you essentially want the max speed and the minimum speed in order to figure out what you could round it to. So to work out the maximum speed, and this is where it's sometimes helpful to just pick two numbers. So if I literally picked 10 and 2. So 10 is my upper bound, 2 is my lower bound. What gives me the biggest output, biggest value? So 10 divided by 2 is 5, and 2 divided by 10 is 0.2. So when I do upper bound over lower bound, that gives me a max value. And when I do lower bound over upper bound, that gives me the minimum value. So you can use that shortcut if you already know that you just do these two. If not, then just do all four options and you'll get something. So let's do that. So to work out the max speed, I'm going to do upper bound divided by lower bound. So upper bound of distance is 2.85. divided by lower bound of time is 0.095694, which is 2.85 divided by 0.095694 is 29.78229318 kilometers per hour, which is pretty fast. Cocker Spaniels are very fast and amazing creatures. So the min speed is, I'd need the lower bound of distance, so that would be 2.75 divided by the upper bound of time, which is 0.095972 recurring. So let's just type that into the calculator. 2.75 divided by 0.095972 recurring. And that is 28.65412,446. So this is like the fastest way to do it, using those two. But like I said, if bounds is something that you struggle with, just do all four options. Like just mix them together and then you'll get four answers, and then you'll be like, oh, well, to one decimal place, they all round to this. So it says by considering bounds, calculate the value of S. So this is the maximum speed. This is the minimum speed. Well, let's see. What do they round nicely to? That's a bit annoying. So it would be very nice if they rounded to one decimal place. So if I rounded it to one decimal place, that would be 28.7, and this would be 29.8. So I'd have to round it. If I rounded it to the nearest whole number, that would be 29, and that would be 30. So I'd have to actually round it to one significant figure. So I'd say 30 kilometers per hour to one significant figure. And if you had the other two values, you would have just got two values that are in between and you would have come to a similar conclusion. But that is how we do some simultaneous equations, but they are not your normal simultaneous equations. They are quadratic or non-linear simultaneous equations. So what you want to do here is essentially you're going to have one, most likely, you're going to have one equation that is linear. And what you want to do is rearrange it so that it's either equal to x or y. I think the easiest thing to do is to just say x equals 4 plus 2y, or x equals 2y plus 4. And then, so step 1, rearrange the linear. And step 2, once you've done this, literally just substitute into the quadratic. So I know that x is this, so I'm going to substitute that into the quadratic. So I'll be left with 2 lots of 2y plus 4 squared plus 8y squared equals 20. Now be careful here because 2 is being times by this, but BIDMAS applies, so I need to square this first. So let's do that, 2y plus 4 squared. And then I've got plus 8y squared equals 20. We'll deal with that later. So 2 times by 2y times 2y is 4y squared. 2y times 4 is 8y plus 16. So all of this is being times by 2. Then I add on 8y squared and it equals 20. So let's just double it. So that would be 8y squared plus, that would become 16y. So times by 2 is 32y plus 20. Okay, so I've expanded this. Then I add on 8y squared and it equals 20. So we're going to need a little bit more space here. So now I can simplify. So 8y squared plus 8y squared equals 16y squared. 32y doesn't have anything to simplify with. And then 20 minus 20 oh, that's 16, not 20, that's why. 32. I was thinking something was wrong. Okay, so 32 take 20 is 12. Because, and the reason I've done this, I've just moved that from both sides because in order to solve a quadratic, you need to make it equal to 0. So now I've got this, and because it's equal to 0, what I can do is I can manipulate it a bit. So I can divide everything by 2. So that would be 8y squared plus 16y plus 6 equals 0. And I could divide it by 2 again. 4y squared plus 8y plus 3 equals 0. And then I have a quadratic, which I can factorize. So you could use a quadratic formula, or you could just use this little thing where you know that if it was 4y squared, the only factors of 3 would be 3 times 1. 4 take 3. So that wouldn't work. So you know that it would have to be 2y squared. If you like the quadratic formula, just do that. I just prefer this because, I don't know. So what do I have to do? I think to myself, what two numbers multiply to make 3? 3 and 1. So 3 and 1. And then how can they make 8? Well, positive 3. 2 times 3 is 6. So that would be 6y. I don't know why I put squared. That would be 6y, and 2y times 1 is 2y. So when you add them together, that makes 8y. So factorize, that would be 2y plus 3, 2y plus 1 equals 0. Again, you can just use a quadratic formula. That's absolutely fine. And then what I do is I just use one bracket at a time. So 2y plus, oh no. So it just decided to shut down and restart itself. So I lost my working. But thankfully I have a memory of, I don't know, a goldfish. I think I can remember. So that was, what did I say? 3 and 1. Yeah, so that would have been 6y, 2y, so that works. Okay, so 2y plus 3 and 2y plus 1 is one of my brackets. It equals 0. So I'm just going to treat them each one at a time. So 2y plus 1 equals 0, therefore 2y equals minus 1, therefore y equals minus a half. So one of my y values is minus a half. Oh, top tip, you're always going to get, well generally, you're always going to get four solutions, 2 x values and 2 y values, because a quadratic and a linear, when they meet, there's 2 sets of coordinates, x, y and x, y. So just bear that in mind. And then I'm going to do this bracket, so 2y plus 3 equals 0, so 2y equals minus 3 and y equals minus 3 over 2. Okay, so I've got those values, so let's just write them up here and get rid of all of this because I don't need it anymore. So my y value is minus a half and also minus 3 over 2. To work out my x value, all I need to do is substitute that y value into one of the equations. Now, the easiest one to do would be the linear equation, so it just makes your life easier. So we could rearrange it so that it was x equals 2y plus 4, just to make it easier to work with. So when y is a half, x is going to be 2 times by minus a half plus 4. So 2 times minus 0.5 is minus 1 plus 4 is 3. So if they wanted it as coordinates, you would write 3 minus a half, but they haven't said that. So you just say x is minus a half, y is minus a half, x is 3. And then if y is minus 3 over 2, x is going to be 2 times by minus 3 over 2 plus 4. And 2 times minus 1.5 plus 4 equals 1. So if it was coordinates, it would be 1 minus 3 over 2. But they haven't asked you for coordinates, and sometimes they take off marks if you write it as coordinates and they haven't asked you. So just make sure that you write it in a nice, clear way. So a nice, clear way of showing it would be when y is a half, x equals 3. When y is minus 3 over 2, x equals 1. That's just a nice way of showing the examiner you've worked a bit of a nasty, well, not nasty, just challenging question. Well, just not even it's just a long question that just requires you to go through the process. So the key thing that we need to remember is that in order to add or subtract fractions, they just need the same denominator. Okay, so that's the key thing that you just need for basic fractions, algebraic fractions, any kind of fractions. So what we want to do is probably just start with this bit and ignore the minus 3 till later. Just separate it and work on bit by bit and simplify it and then bring everything together. So in order to add these two together, I'm going to need to write them as fractions that have the same denominator. And in this case, because they're algebraic fractions, I'm just going to not worry about finding the lowest common multiple. I'm just going to write it as x minus 4, x plus 4. So what I do essentially is, let's say you had a over b plus c over d. The lowest, sorry, your common denominator would have to be bringing both these denominators together. So your common denominator would be bd. And then what have you multiplied this fraction by to get to bd? You've multiplied by d, so that would become ad plus cb, because what have you multiplied this by, you've multiplied it by b. So essentially we do exactly the same with algebra. So let's say it was a over x minus 4 plus b over x plus 4. What am I doing? My common denominator is going to have to be the two denominators multiplied together. And then you just think to yourself, what have I multiplied this by to get to this denominator? Well, I've multiplied by x plus 4, so I need to do the same to the numerator. And similarly here, what have I multiplied this denominator by? I've multiplied by this, so that would need to be like that. So hopefully that simplifies it a little bit, but that's why this becomes the denominator. So using that method, what have I multiplied this fraction by to get to this denominator? I've multiplied by x plus 4. So whenever you are changing a fraction, in order to keep it in the same proportion, you need to multiply whatever you've multiplied the denominator by, you need to multiply the numerator by the same thing, otherwise you change the value of the fraction. So that's why I'm doing this. So that would become x minus 3, x plus 4, plus, and then this fraction here I have multiplied by x minus 4, so that would be 2x plus 2, x minus 4. Now, let's just clear this up and make it a little bit neater. So, I write all of this under one fraction, x minus 4, x plus 4, and then this, x minus 3, x plus 4, plus 2x plus 2, x minus 4 is the next part of just like simplifying that. So generally with algebraic fractions, you're going to have to do some manipulation. You're generally going to have to expand the brackets, factorize them, just keep expanding and factorizing until something clicks. So over here, I know that my ultimate aim is to get the denominator in this form, and that's pretty simple because I can tell that this is going to be the difference of the two squares. So if I actually expanded that, x minus 4, x plus 4, x times x is x squared, 4 times x is 4x, minus 4x, and then minus 16, that cancels, so already I'm left with that. So you could start by just simplifying your denominator and show you're working like I have a small x space to work in, but you have good working on your big page. So that's step 1 for the denominator. Working out 2, I'm going to expand this bracket. So x minus 3, x plus 4 is x squared, plus 4x minus 3x minus 12, so that would simplify to x squared plus x minus 12. And then I'm adding, this is where it's annoying running out of space, I'm adding, so that's my working for 1 and 2. Now let's do the working out for the third part, so this part here. So 2x plus 2, x minus 4, expand it, that would be 2x squared minus 8x plus 2x minus 8. Simplify, so minus 8 plus 2 is minus 6. So then you've got this, 2x squared minus 6x minus 8. Now, we can see if we can simplify it. So x squared plus 2x squared would give me 3x squared. X minus 6x is going to be minus 5x, and then minus 12 minus 8 is minus 20. So I'd be left with this, which I could factorize if I wanted to. There's a few, I mean, there are actually so many ways that you can do this. So the key is just expanding and factorizing and manipulating it until you can simplify it. But the point is that I have now simplified this to this. I could then factorize the numerator, but I'm not going to, not just yet. Because what I then need to do is subtract 3. So to turn any number into a fraction, you just write it as over 1. So that would become 3 over 1. But in order to add or subtract fractions, they need to have the same denominator. So because this is 1, and when I multiply anything by 1, it stays the same. This fraction is going to stay the same because all I need to do is multiply this fraction by x squared minus 16 so that they have the same denominator. So this would become 3 brackets x squared minus 16 over x squared minus 16. Now, what I can do is expand this. So that would become 3x squared minus 5x minus 20 minus, and then 3 times x squared is minus 3x squared, and then minus 3 times by minus 16 is going to be plus 48. Let's just double check, because honestly, sometimes it's the simple things that lead to the whole question going wrong. So thankfully that's right. And that is all going to be over x squared minus 16. So let's clear this up and continue simplifying. So 3x squared minus 3x squared cancels. Then you're left with minus 5x and then minus 20 plus 48. So 48 take 20 is 28. Have I missed something? Maybe not. No, I'm sure it's fine. So it's not always, sometimes people get really confused by this because they're like, it's not a positive. It doesn't matter. All it means is a and b are integers, which they are. So you could leave it as minus 5x plus 28 is over x squared minus 16. Or you could say 28 minus 5x over x squared minus 16, because it's just nicer not having a, what's it called, negative as the beginning. And you need to find the value of a and the value of b. So the value of a is minus 5 and the value of b is 28. There is a possibility I may have slipped up somewhere, but I'm trying to get this done so it can be released in time. Okay, so the next up is another slightly tricky algebraic fraction one. This time it's division. So with adding and subtracting, you need the same denominator. With division and multiplying, you don't need to bother. You don't need to worry about denominators, okay? All you need to know is for multiplication, you just multiply the numerators together and you multiply the denominators together. And then for division, you remember keep, change, flip, and that's it. So show that this can be written in that form. So all we're going to do is keep the first fraction as it is, change the second fraction. So 8x cubed, oh, this should be pink because it's a pink thing. So 8x cubed divided by 4x squared minus 36 times by 2x minus 3 over 4x to the power of 4. Now, you might not, but hopefully you're getting good at spotting the difference of two squares. So the difference of two squares is literally where you have a square number, x squared, minus another square number. And the way the difference of two squares factorizes, it's always going to be x plus the square root of 16, x minus the square root of 16. So essentially x plus 4, x minus 4, like the square root of whatever your number is. So in this case, I know that this is going to factorize to 2x plus 6 and 2x minus 6, because 4 is a square number, so the square root of 4 is 2, and 6 is a square number, and the square root of 6 is 36 is 6. And the reason this always works is because when you expand it, because you've got one positive and one negative term, the middle two terms, they always cancel out. So let me just show you, if you don't believe me, that would become 4x squared minus 12x plus 12x minus 36. So this and this cancels out, and that is why you're left with 4x squared minus 36. So it's really important that you always look out for things like that, because in this case, I'm pretty sure it's going to matter. So I'm just going to rewrite that to make my life easier. So 2x plus 6 and then 2x minus 6 times by, and already I can see that that's making a difference. So if I expand this, that would be 2x minus 6 over 4x to the power 4. Now remember, when you're multiplying, you just multiply the numerators together and the denominators together. So that would be 8x cubed times by 2x minus 6 over 2x plus 6, 2x minus 6. You could write it like that if you wanted to. I'm just writing it like this just to show you, so that it might make it a little bit easier. So then remember, with a fraction, if you had, like, let's say 5 times 4 divided by 5, well, 5 divided by 5 is 1. So anything, so that would just end up being 4 over 1. So whenever you have anything on the top of the fraction that is the same as the bottom of the fraction, oops, was that minus? Yeah. They cancel out so long as the numerator and the denominator are products, which means every term is being multiplied. And it can be like things inside a bracket can count as one term, sort of. So I've then simplified this, and let's rewrite it over here. So once I've cancelled that out, I end up with 8x cubed as my numerator, and then 4x to the power 4 times by 2x plus 6. Now, there is a little bit of a hint over here. I know that I'm going to eventually divide, I want my numerator to be essentially divided by 8x cubed. So what that means, because I want it to be 1, the only way to get 1 is to divide 8x cubed by 8x cubed. So what that means is that I could take out a multiple of 2 from the bracket. So that could become 8x cubed divided by 4x to the power 4 times by, if I take out 2 out of the bracket, I'd be left with x plus 3. And 4x to the power 4 times by 2 is conveniently 8x to the power of 4. So I'd be left with 8x to the power 4 times by x plus 3. Now, if you're not confident with indices and you look at that and you're like, oh, I'm just brain fried, literally just take it back to its basics. So what does 8x cubed mean? It means 8 times x times x times x, and then 8 times x times x times x times x times by x plus 3. That's in a bracket. So what can cancel out? Well, 8 divided by 8 is 1, x divided by x, x divided by x, x divided by x. So the whole of the top cancels out to just 1. And on the denominator, you are left with x plus 3 and 1x on the outside. And there we have it. They haven't asked you what a is, but if they did, you would say that a is 3. So hopefully that helped a little bit. And the key is just keep going with the question and see where it takes you. And I am told to find an expression in terms of n for the sequence. So the first thing I do, just like I would with a linear sequence, is just figure out what the term to term difference is. So from 7 to 13, what do? I add 6. From 13 to 27, what do? I add 14. From 27 to 49, I'm going to use a calculator because the brain is really flagging right now. 49 take 27, I add 22. And 79 take 49 is 30. So that is the first difference. Now, with a quadratic, the first difference isn't going to be the same. So what we do is we then find the second difference. So 14 take 6 is 8. 22 take 14 is also 8. And 30 take 22 is also 8. So my second difference is 8. Now, whatever the second difference is, halve it. And then that tells you what n squared the sequence is going up in. So it might be useful to just remind yourself of what the square numbers are. So it's 1, 4, 9, 16, 25. So this sequence is going up in the 4n squared times tables. So it's just helpful to just write it out. So if n squared is 1, 4n squared would be 4. 4 times 4 is 16. 9 times 4, it's really flagging. 9 times 4 is 36. 16 times 4 is 64. So this is the quadratic sequence it's going up in. So what I can do then, once I found my second difference and I halved it, that tells me what n squared is going up in. So I know it's going up in the 4n squared times table, so that will be the first part of my sequence. I then write out this second sequence above my original sequence. So that would be 4, 16, 36, 64. And what I want to do is find out, so I could do it in a table as well. So 4n squared and then original sequence. So 4n squared is 4, 16, 36, 64. The original sequence is 7, 13, 27, 49. And what I want to do is figure out what the difference is between the 4n squared times table and my sequence. So how do I get from 4 to 7? I add 3. How do I get from 16 to 13? I take 3. From 36 to 27, I take 9. And from 64 to 49, I take away 15. Okay, so then I have this new sequence that's going to tell me the next part. So I know the first part of my sequence is 4n squared, and the next part is just work out the nth term of this sequence. Okay, so the sequence is 3 minus 9 minus 15. What's the difference? Well, it's going down by 6 each time. So the nth term of this sequence, if it was the minus 6 times tables, is minus 6n. And then how do I get from minus 6 to 3? I add 9. From minus 12 to 3, from minus 12 to minus 3, I add 9 as well. From minus 18 to minus 9, I add 9 as well. So the nth term of this sequence is minus 6n plus 9. So once you've got that, you just lumber it on to this. So my full sequence would be 4n squared minus 6n plus 9. So step 1, find the second difference, halve it, and that tells you what n squared times table it's going up in. Then work out the difference between the n squared and your original sequence. You could have done it like this if you preferred, whatever you prefer. And then you just work out the nth term of this sequence, and that tells you the whole thing. So the nth term of this sequence is 4n squared take 6n plus 9. Now I'm next being asked to find the 20th term of the sequence, so all I do is I substitute n equals 20. If I was asked to find the 40th term, I'd substitute n equals 40. So that would be 4 times by 20 squared, take away 6 times 20 plus 9. So 4 times 20 squared is 1,600, take away 120 plus 9. So 1,600 take 120 plus 9 equals 1,489. And that's how I do that. I know there are other ways, I don't like them, but if you know the other way and you get the same answer, absolutely. Nice circle theorem. So I'm told that B, D, E and F are 4 points on a circle, and the ABC is a tangent to the circle. So automatically I should be either thinking tangent and a radius, which doesn't apply here because there is no radius, or tangent and a chord. What do I know about a tangent and a chord? That is where I have the alternate segment theorem, and that states that essentially if you have a tangent and it intersects a chord, then the angle formed, so this angle here between the tangent and the chord, so in this case this angle here, the angle formed between the tangent and the chord is going to be equal to the angle in the alternate segment. So if you look at the chord, this is the segment the first angle is in. So this whole thing is going to be the alternate segment. But some people find that confusing. So if you just think about it as this is the chord, okay, so this angle and this angle are touching the chord, so they cannot be the alternate segment, then the only angle that is left is this one over here. So that's the alternate segment theorem. So that should spring to mind. And then what else? Well, sneaky. This is sometimes sneaky because people just find it hard to visualize, but that's why it's good to have a highlighter and just literally go around and see what shapes you can make out. This is a cyclic quadrilateral, and you know that cyclic quadrilateral, in a cyclic quadrilateral, and that is when all of the vertices are touching the circumference of the circle, which this one is, opposite angles sum to 180. So these are the two circle theorems that are screaming out at me initially. So let's see if they apply. So angle DBE is 25 degrees, great. The sines of angle BDE, so this angle here, to BFE, this angle here. Okay, so what is good about this is that already I can see that these, if I think about it as a quadrilateral, so remember that you can think about the whole thing as a quadrilateral, I know that these two angles must sum to make 180. So let's try that again. So BDE is 3 parts. So let's just call that 3x to 2x, just so that I have something. It's in the ratio 3 to 2, so whatever the angle is, I can call that. I don't know why I'm struggling to explain why you turn it into 3x. So what a ratio 3 to 2 means is that for every 3 parts, or let's say degrees, for every 3 degrees that this angle has, the other angle has 2 degrees. So whatever the degrees is, 3 lots of x is this angle, and this angle is 2x. And the reason I do that is because I can then form an equation. So 3x plus 2x must equal 180. And the reason would be cyclic quadrilateral sums to 180. So 5x equals 180. So therefore x equals 180 divided by 5, which is 36 degrees. Therefore, 3 times 36 is 108. So this angle here, oh, why does it do that? So this angle here is 108 degrees, and then 2 times 36 is 72. So this angle here is 72 degrees. Okay. Now, there are, sorry, there are a few ways that we can go about the next part. So one of them is using the alternate segment theorem. So there's actually just so many ways that we can do this, but let's have a look at this. So this is a chord, and this little angle here must be equal to this little angle here, and I could go about that way if I wanted to. Yeah, why not? Let's go about that way. So if I just took this triangle out, I know that this is 25 degrees, this is 108 degrees, so I could work out what this is by just doing 180, take 108, take 25 equals 47. And I'd say, because as angles in triangles sum to 180, don't forget your reasons. It's really important you write your reasons, because without reasons you don't get the marks. Even for the basic things, and obviously for the alternate segment theorem, you would have written, actually for the alternate segment theorem, you can just write alternate segment theorem, that's okay. So therefore, this little bit here is 47 degrees. And what are we trying to work out? ABD. Okay, so we've worked it out. So ABD is 47 degrees. Another way you could have done it is, you know that this is a chord as well. And all of this, so the angle between the tangent and the chord is equal to the angle in the alternate segment. So all of this must have equaled 72. So you know that this angle, 25 degrees, and this must sum to 72 degrees. So 72 take 25 is 47. That's another way you could have done it. There are loads of other ways that you could have done it, but essentially alternate segment theorem, cyclic quadrilateral is the key circle theorems that would have been used here, and hopefully they make sense. So here's another circle theorem. So ABCD are 4 points on the circle. BCE is a straight line. Angle DAC is 25 degrees. And then we know that these two sides are the same, as are these two. So I know that they're going to form isosceles triangles. Okay, so what can I do first? The ultimate aim is to work out what this angle here is. I can deal with that later. First, let's deal with what I know. So that's 25 degrees, which means that I can work out what these two angles here would be. So 180, take 25 is 155, divided by 2 is 77.5. And the reason I've done this is because AD equals AC, therefore triangle ADC is isosceles, and base angles of an isosceles triangle are equal. So it wants reasons, so that would be my reason. Next, I know that AB equals BC. AB equals BC, therefore triangle ABC is isosceles. So if I can work out any of the angles, then I know that I can do stuff with them. So let's try and think outside the box. So like I said, always have highlighters and highlight round just to see what shapes are present. You're always looking for either triangles, tangents, cyclic quadrilaterals, and in this case you have a nice cyclic quadrilateral here. Sometimes it's hard to spot, which is why I really push the highlighter technique. Just try and highlight as many different things as you can, otherwise you won't be able to do the question. So opposite angles, so we'll save this reason till later. So opposite angles in a cyclic quadrilateral sum to 180 degrees. Therefore, I can figure out what this angle here is. Therefore, angle ABC equals 180 take 77.5, which is 180 take away 77.5 equals 102.5 degrees. So this angle here is 102.5 degrees, and this is isosceles. Therefore, angle BAC equals angle BCA, as base angles are equal. And the working I do is 180 take away 102.5 divided by 2, because there's 2 of them. So 180 take away 102.5 leaves me with 155 over 2, which is 77.5. So 77.5 divided by 2 leaves me with 38.75. So these two angles are 38.75. Okay, so now I have essentially all the angles I need, because the last part is that this BCE equals straight line So all angles sum to 180. Therefore, angle DCE must equal 180 take away 77.5 take away 38.75, which equals 180 take away answer take away 77.5 is 63.75. And those are all the reasons that you should give. So recognizing that it's an isosceles triangle, saying what that means. The cool thing about an isosceles triangle is it's got two equal sides and two equal base angles. And then spotting the cyclic quadrilateral, and then the last bit is just a straight line. So these are pretty simple steps. That the issue with circle theorems is spotting it. So highlight everything that you can to try and just pick out shapes and things, and always just start by working out the things that you know. Now, if you've made it through this video, I don't even know how long it's going to be, but I think it's going to be pretty long. Can you just leave a comment, because you deserve some kind of accolade for going through all of this. So let's do the last question. So here is a frustum of a cone. All a frustum means is literally like a cone or a pyramid or something, and it's had its top chopped off. So you're left with this kind of where are you? Yeah, this kind of weird shape thing. Okay, that's all a frustum is. So here is a frustum of a cone. The diagram shows that the frustum is made by removing a cone with height 2.8 from a solid cone with a height of 5.4 and a base diameter of 8.1. So step one, I am going to need to use my formula for the volume of a cone, which is kindly given to me. And that is 1/3 times by pi r squared times by the height. So let's start with working out the volume of the large cone equals, okay, so what am I going to do? I'm going to do 1/3 times by pi times by 8.1 squared, because that is the, oh no, I'm not. See, this is where it's good to write out the formula. They want the radius, not the diameter. So 8.1 divided by 2 is 4.05. So 4.05 squared times by the height, and the height is going to be all of this. So 2.8 plus 2.8 is 5.6. Okay, so that is going to tell me the volume of the large cone. So let's just type that into a calculator. 1/3 times by pi times by 4.05 squared times by 5.6 equals 96.1892837 centimeters cubed. Now we need to work out the volume of the small cone. So there's a few ways we can do this. They are going to be similar shapes because they are literally made of the same thing. So you can either do it by working out the linear scale factor, or you can use the volume scale factor when you've got similar solids. I don't know which would be easier. So, oh no, don't delete. Why does it do that? Okay, so essentially you've got this cone and this large cone, and you know that they are similar, so you know that they have a scale factor. So the height of the large cone is 5.6, the height of the small cone is 2.8. So therefore, the linear scale factor is, how do you get from the small cone to the large cone? You just times by 2. So therefore, to get from the large cone to the small cone, you divide by 2. And if the radius of the large cone is 8.1, the radius of the small cone is going to be half of that. I'm going to have to divide by 2. So let's just write that out there. So to remember, so diameter. So diameter of small cone is going to be 8.1 divided by 2, which is 4.05. And I need to know the radius, so I'm going to have to divide that by 2 again. So that is 2.025. So to work out the volume of the small cone, I'm going to do a third times by pi times by 2.025 squared times by the height, which is 2.8. So 1/3 times by pi times by 2.025 squared times by 2.8 is 12.023666048. So a lot of work for just the first part of the question. Now I need to work out the volume of the frustum, and to work out the frustum you literally do large cone take small cone. So that's going to be 96.189 take 12.02. So 96.189 28387 take away answer equals, so volume of frustum equals 84.16562339. Right, excellent. So I know that that is the volume of my frustum. I then am told that the frustum is joined to a solid hemisphere. So this is the hemisphere, it's half of a sphere, which has the same diameter to form a solid. So it's literally got the same little circle as its base, and they smush it together and it forms this nice strange shape. Okay, so we're talking about density here. So I'm going to need to work out what the volume of this hemisphere is first. So the volume of a sphere is 4/3 times pi times r cubed, but I want to half it, so I either divide it by 2 or I times it by a half. So what's the radius? Once again, that's 8.1 divided by 2 is 4.05. So I'm going to do 4/3 times by pi times by, did I say 4.05? Yep, 4.05 cubed equals, divided by 2 equals 139.1309285. So that's the volume of the hemisphere. So because I'm talking about density, and I've got two different materials that have different densities, I am going to need to do some working out. So it really helps actually to do a two-way table to just gather all of this information. So you've got your density, mass, and then volume. Let's make this a bit bigger. Okay. Why is this failing? Okay, and then you've got frustum and hemisphere. Call you hemi. So now let's put all of the information that we have. The volume I have worked out of the frustum is 84.165. The hemisphere is 139.13. I've got the full values here. Mass, I don't know, but the density I've been told, so frustum has a density of 3.2 grams per centimetre cubed, and hemisphere has 6.8 grams per centimetre cubed. So all that is left is to work out the mass, and I need to know the mass because to work out the average density I need the total mass divided by the total volume. This is why this is a little bit of a nasty question. So what's the formula for density? Well, density is mass over volume. So therefore, to work out mass, I just do density times volume. So I still have 139 saved in my calculator, so I'm just going to times that by 6.8. Whoa. Okay, so that's a mass of 946.09. All these numbers. So mass of hemi is 946.0903135. And then I've got 84.1656239 times by 3.2, which is 200. Let's write it here. Mass of I'll call you Frosty because I think I'm slightly unhinging. Okay, 269.329915. Right, so we've got the mass. So let's add the two together. So plus 946.09 equals, right, so the total mass, don't do that. Okay, total mass is 1,215.419991. The total volume is 84.16562339 plus 139.1309285, which equals 223.29655519. How do you work out density? Density is mass over volume. So I'm just going to do 1215.419991 divided by answer equals 5.4430755501. They haven't said what they want it to, but normally it's three significant figures. So we could say the density equals 5.44 grams per centimetre cubed. And there we go. That is the final question. Hopefully some of this has been helpful, and I know it's not long until your exam, so hopefully this is out in time.